Hello there and welcome to Just About Earth, where curiosity settles in beside you and the questions we ask are allowed to stretch out, take their time and wander a little before they decide where they're going. Tonight we're going somewhere much older than the clocks that mark our days or the timelines written in our school books. Somewhere quiet and sandy and patient. Somewhere that has been waiting far longer than the years we've counted. Because this evening, we're going to explore a possibility that sits right at the edge of what we think we know. A possibility that might reshape not just our understanding of the past, but the entire story we tell about ourselves. What if the pyramids are older than all of human history? Even saying it out loud feels like brushing dust off something hidden. The kind of idea that makes you lean in a little, not because it's loud or dramatic, but because it carries that gentle tug of mystery. The pyramids have always been symbols of endurance, but what if they have endured far longer than we ever imagined? Longer than the rise and fall of kingdoms, longer than the invention of writing, longer than the histories that attempt to explain them, and longer perhaps than the very version of humanity we believe built them. But before we let our minds drift toward those towering shapes in the desert, glowing gold in the late afternoon sun, I'd like to ask you something simple. Where are you listening from tonight? What does the world look like around you in this moment? Is it quiet? Is it late? Are you wrapped in a blanket or lying back on a pillow, letting the edges of your day soften a little? Wherever you are and whatever the time might be, thank you for bringing your evening or your morning or whatever slice of your day this is into this little calm corner of curiosity. And if you find the gentle unravelling of questions like this soothing, if it helps you relax or wind down, or if it simply gives your mind something soft and steady to drift through, I'd be grateful if you tapped like or subscribed. It helps this peaceful space find others who might enjoy a slow exploration of something ancient and strange. But there's no rush. You can settle in at your own pace. Now that we're here, let's begin to walk slowly toward those pyramids. Not the ones crowded with tourists or printed on postcards, but the ones that exist in your imagination. The ones surrounded by quiet. The ones standing alone at the horizon the way they must have thousands of years ago, before the world became noisy with engines and cities and screens. When you picture them that way, it becomes easier to feel the weight of the question we're about to follow. Most of us learned in school that the Great Pyramid of Giza was built about 4,500 years ago. That puts it around 2500 BCE, long after agriculture began, long after the first cities rose along rivers, long after writing was invented. We're told it's old, very old, one of the oldest monuments on Earth. But what if it isn't just old? What if it's ancient in a way that shifts everything? What if the pyramid isn't just a remarkable engineering achievement from a rising civilization, but a relic left behind by something earlier, something we don't yet have a name for? Just the idea of that opens a door in the mind. Because if the pyramids are older than all of recorded history, then the story of humanity is not a straight line from simple to complex. It becomes something else entirely, something with gaps and forgotten chapters, something that might have started, stopped and started again. That thought isn't loud or dramatic, it's the kind that sits quietly and lets you lean closer. Before we dive into any theories or debates though, it helps to pause here at the threshold of the question and sit with what it means to imagine the past differently. History often feels settled. We're taught that archaeologists and scientists have traced the lines clearly, that ancient people lived in one era and modern people in another, and that the beginning of civilization sits neatly at a point on a timeline. But if you've ever walked into a museum or looked at an ancient ruin and felt that small hum of mystery, you already know that the past is much bigger than the lines we draw. It doesn't always fit neatly into our labels. Sometimes it spills out quietly, reminding us that we may not know as much as we think we do. The pyramids invite that feeling more than almost anything else humans have ever built. They stand there in the bright desert light, massive and silent, as if they're guarding something. They don't shout their history, they don't give it away easily. They hold on to it stone by stone, layer by layer, letting only hints slip through the cracks. Part of why the idea of an older pyramid is so compelling is because of how strange the pyramids already are. Even if we accept the standard timeline, they're mysterious. Built with extreme precision, aligned to celestial bodies, constructed using methods we still debate, made from stones so large that the logistics alone stretch the imagination. And all of this supposedly accomplished by a civilization that, according to the timeline, hadn't yet reached many of the technological milestones we associate with such feats. If the official story feels incomplete, that's not a criticism of historians. It's simply a reflection of how enormous the past is. Most of it didn't leave written records. Most of it left nothing behind at all. Human history is like a book where almost all the pages are missing, and we're doing our best to understand the story from the few that survive. So when an idea like this comes along, when someone whispers that perhaps the pyramids aren't just ancient but much older than we think, the question isn't absurd. It's an invitation to consider the possibility that human civilization might have deeper roots than our textbooks suggest. That maybe the rise of organized societies didn't begin 5,000 years ago, but tens of thousands of years earlier. And that somewhere in that vast expanse of time, there might have been cultures capable of building structures we struggle to replicate even today. You don't need to believe the idea outright to explore it. You just need to be curious enough to follow the thread. And that's what we'll be doing gently, step by step. Not rushing toward a conclusion or trying to prove anything. Just allowing the question to guide us deeper into the desert, the stone, the timelines, and the possibilities. Imagine for a moment that you're standing at the foot of the Great Pyramid at dusk. The sun is low behind you, casting long shadows across the sand. The stones in front of you are enormous, larger than they seem in photos. They stack upward in a shape so precise and so intentional that you feel a small ripple in your mind. Something about it doesn't feel improvised. It doesn't feel experimental. It feels like the work of a culture that was confident, capable, and deeply practiced. Something that had built in stone before. Something that had a long tradition of expression through architecture that didn't begin or end with these walls. You stand there looking up, and the question becomes harder to ignore. Does this structure feel like the beginning of something, or the continuation of something older? If a civilization suddenly mastered engineering on this scale, where are the earlier attempts, the prototypes, the learning stages? The pyramids themselves don't show the hesitations of beginners. They feel like perfection emerging from somewhere further back than we can see. That feeling is part of what draws people to this topic. Not the desire to rewrite history recklessly, but the quiet sense that something doesn't quite line up. When you look at the pyramids long enough, you can't help but wonder whether the story we've been told is complete, or whether it's only the part we've uncovered so far. And that's where this journey takes its first real step. Because if the pyramids might be older than we think, then evidence should exist somewhere. Perhaps not in the form of clear proof, but in the form of small clues, tiny inconsistencies, anomalies in the stone, erosion patterns that don't match the climate of the era they're assigned to, architectural methods that appear fully developed without any earlier evolution, legends that hint at lost ages, and changes in the environment that suggest parts of Africa and the Middle East once looked very different than they do today. We'll explore all of that soon, but before we do, it helps to settle into the mindset that makes this kind of exploration useful. A mindset that treats the past not as a fixed map, but as a landscape still being uncovered. A landscape full of valleys and caves and hidden paths where new discoveries sometimes reshape what we thought was solid. The truth is that history is not finished. It's ongoing. Archaeology is constantly finding new sites, new artifacts, new data that challenge older assumptions. Just in the last few decades, discoveries like Göbekli Tepe have pushed the timeline of organized construction and symbolic culture thousands of years earlier than expected. What was once considered impossible for prehistoric people has now become part of our accepted timeline, and if the timeline can shift once, it can shift again. So when we ask, what if the pyramids are older than all of human history, we're not wandering into fantasy. We're stepping into a space where curiosity meets possibility, where the known meets the unknown, and where the stones standing in the desert might hold answers we haven't yet learned how to read. As we move forward, we won't be trying to prove anything dramatic. The goal isn't to claim that an advanced lost civilization definitely existed, or that ancient people spoke to the stars or possessed forgotten technologies. The goal is simply to explore the idea with calm, steady curiosity, to ask what it would mean if the timeline were larger than we thought, to look at the stones carefully, to listen to the land and to consider how much can hide beneath sand and time. As you settle deeper into this quiet exploration, you might notice your thoughts slowing a bit, the way mine do when I picture those massive structures silhouetted against the darkening sky. There's something peaceful about imagining the distant past, something grounding about remembering that human beings have been building, dreaming, questioning, and reaching upward for far longer than we tend to acknowledge. And maybe, as we go further, you'll find yourself wondering about the people who lived before the rise of recorded civilizations, the ones who left no writing, no archives, no official records, the ones who might have lived in harmony with a world that looked different than ours, the ones who might have passed down knowledge through voices and memory before the sand slowly covered their traces. Tonight, we're going to take our time walking toward that possibility. There's no need to hurry. Each idea will lead gently to the next. Each question will open the door to another, and somewhere in that slow unfolding, we'll begin to see the shape of a much older world. One that might have existed before the history we know. One that might have left behind the pyramids as a quiet whisper to the future. When you first begin thinking about the possibility that the pyramids might be far older than we've been taught, there's a particular kind of question that settles into the mind. It doesn't arrive with certainty or bold claims. It starts as something quieter, something almost hesitant, like brushing sand away from a small part of a much larger shape. You don't know what the shape is yet. You just know that something is there, something that doesn't quite fit the neat timeline we've grown comfortable with, something that asks for a closer look without promising clear answers. The puzzle begins with what we think we know. According to the accepted timeline, the Great Pyramid was built around 4,500 years ago during the reign of Pharaoh Khufu. This date is tied to historical records, inscriptions, and long-standing archaeological interpretations. It's the story most of us learned, the one that's easy to organise and remember. But as with many areas of the ancient world, the closer you look, the more the edges blur, the more questions start to appear in the gaps, and the more the sand begins to shift beneath your feet. One of the first pieces of this puzzle is simply the structure itself. When you examine the pyramid up close, you notice how little about it suggests experimentation. There are no smaller, earlier versions showing the evolution of technique. There's no clear record of trial and error. Instead, it appears suddenly in the archaeological record as an architectural achievement that seems fully mature the moment it arrives. That would be like discovering the first painting in human history, and finding out it was a lifelike portrait instead of a set of crude lines. It doesn't prove anything by itself, but it does make you wonder what came before it, if anything did. The feeling that it might not be the first of its kind, but instead the peak of a tradition that hasn't survived in the evidence we've found. Another piece of the puzzle is found in the stonework. The blocks used to build the Great Pyramid are not just large, they are massive. Some weigh as much as 50 or 60 tons. Others are smaller, but still far beyond what any modern builder would choose to move without specialised equipment. And yet, whoever built the pyramid managed to transport, position, and align these blocks with remarkable precision. Joints between certain stones are so tight that even the thinnest blade can't be inserted between them. For a project supposedly executed by a culture without the wheel, without advanced pulleys, and without iron tools, these details raise questions. Not accusations, not definitive contradictions, just quiet, persistent questions. The kind that make you look again and think about the timeline you've been taught. Some researchers point to the sheer scale of the pyramid as yet another piece of this quiet puzzle. Not just the height or the mass, but the level of organisation required to complete it. The coordination of labour, the management of resources, the logistical planning, the surveying skills and the understanding of geometry involved. None of these alone are evidence of an older construction date, but collectively they create a feeling that something is incomplete in the story, that a structure so advanced might reflect knowledge that didn't appear overnight or within the span of a single generation. Then there's the alignment. The Great Pyramid is oriented almost perfectly to true north, not magnetic north, which shifts, but the axis of the Earth's rotation itself. Achieving this level of precision is difficult even with modern equipment. With ancient tools, it's extraordinary. Some studies suggest that the pyramid's alignment is accurate to within a fraction of a degree. How exactly the builders accomplished this isn't fully clear. There are theories involving the stars, the sun, or shadows cast by poles, but none have been universally accepted. What's interesting is not that the builders managed such a feat. Human ingenuity is remarkable, and history is filled with moments where people achieved surprising things. What's interesting is how comfortable they seemed with this level of precision, as if this sort of engineering wasn't new to them, as if it came from a deeper pool of inherited knowledge. You don't need to leap to conclusions to appreciate the strangeness. You only need to acknowledge the question that sits beneath the surface, the question that makes the sand shift a little when you step on it. Why does so much about the pyramid feel like the culmination of something rather than the beginning? Another detail that contributes to this puzzle is the absence of written records describing the construction. For a civilization that documented so much of its life, from crop yields to religious rituals, it's unusual that the building of its greatest monument is not clearly described. There are inscriptions in later tombs crediting workers and officials, but no comprehensive record from the time of construction itself. Some find this significant. Others argue that ancient Egypt's surviving texts are only a tiny fraction of what once existed. Either way, the silence is noticeable. Silence is not proof, but it is part of the puzzle. It makes you wonder what was lost, what was never written, or what may have been so familiar to the people of the time that they didn't consider it worth explaining. Then there's the erosion. This part of the puzzle often leads people to look beyond the pyramid and toward other structures on the Giza plateau, especially the Sphinx. The debate around the age of the Sphinx has been going on for years. Some geologists argue that the erosion patterns on the body of the Sphinx suggest exposure to heavy rainfall, the kind of rainfall the region has not seen since long before the rise of ancient Egypt. If the Sphinx is older than commonly believed, some argue that the pyramids might be older too, built during or shortly after a period when the climate was very different. It's not a universally accepted idea, but it's enough to raise eyebrows. Enough to make you wonder whether the sands of time have covered more than just the base of a statue. Even if the Sphinx doesn't reveal a definitive answer, the broader environmental evidence invites questions. The Sahara wasn't always a desert. Thousands of years ago, it was a green plain filled with lakes, rivers and wildlife. Signs of human settlement from this greener era have been found deep in regions that are now inhospitable. That shift in climate, that transformation from a wet world to a dry one, opens up a window of possibility. A window where ancient people might have lived in ways we haven't yet uncovered. A window where complex societies could have flourished and then disappeared as the land dried around them. And if those societies built in stone, some of their structures could still be standing. Others might be buried beneath the sand, waiting for the right moment to resurface. This is where the puzzle becomes more interesting. Not because it offers answers, but because it shows how much we don't know. How many timelines are built on assumptions that might shift as new discoveries emerge? History is not a fixed story. It's a slow conversation with the past, and sometimes the past speaks softly at first. Another thought that arises when you spend time with this puzzle is the issue of lost civilizations. Not mythical ones with impossible technology or fantastical stories, but ordinary human cultures that might have reached levels of organisation and skill we haven't fully recognised. We know that human beings tens of thousands of years ago were capable of symbolic art, seafaring, and long-term planning. We know they travelled vast distances, adapted to changing climates, and developed complex social structures. If even a small group of people from that time invested generations into building in stone, they could have created structures that lasted long enough for later civilizations to rediscover and incorporate into their own cultures. This isn't a wild idea. Throughout history, societies have built on top of earlier ones. Temples have been constructed on older foundations. Cities have been rebuilt where ancient ones once stood. Knowledge has been inherited, repurposed, lost, and rediscovered. The idea that the Egyptians might have found or inherited certain structures or certain knowledge is not outside the realm of possibility. It's simply not part of the accepted narrative because there isn't clear evidence yet. But the absence of evidence in ancient history is not the same as evidence of absence. Most of the past has vanished. Most of the things ancient people made were swept away by time. Only the structures built from the hardest stone remain. This brings us back to the puzzle. If the pyramids are older than we think, the evidence might not be obvious. It might not be a clear inscription or a piece of writing. It might be patterns in rock, unusual alignments, construction techniques that seem out of place, or anomalies in erosion, small clues that hint at something larger. Archaeology often advances through these little inconsistencies. One unexpected find, one mistake in the assumed timeline, one site that doesn't match the standard pattern. Every now and then, those inconsistencies force the entire field to shift. It's worth noting that many of the certainties we were taught about ancient history have been corrected in the last century alone. There was once a time when people believed civilization began in one place, at one time, with one group of people. Now we know that's not true. There were multiple centres of innovation. Farming developed independently in several regions. Writing emerged in more than one place. Monumental architecture appeared in cultures separated by continents and oceans. The story is more complex now, more interesting, and far less linear. When you understand that, the idea of older pyramids becomes easier to consider. Not as a claim, not as a belief, but as a question worth exploring. A question shaped by anomalies, inconsistencies, and quiet hints. It doesn't require us to imagine a lost advanced super-civilization with technology beyond our own. It only asks us to imagine that human beings long ago may have been more capable, more organised, and more connected than we've assumed, and that some of what they built may have survived in fragments, waiting to be interpreted. As you look at the puzzle, another layer begins to reveal itself, the human layer, the awareness that people have always been curious, always innovative, always trying to understand the world around them. It's easy to imagine that ancient humans were less clever or less capable because they lived so long ago, but time doesn't measure intelligence. People of the past thought, experimented, observed the sky, counted the seasons, built tools, solved problems, and worked together. If they faced a challenge, they didn't shrug and give up. They found a way. They tried again. They passed knowledge down through generations. They cared about the land they lived on and the structures they built. If given time and stability, any culture can reach impressive achievements. The puzzle of the pyramids becomes more interesting if you step back and let yourself imagine what thousands of years of accumulated practical knowledge could look like. Imagine generations refining building techniques, understanding the behaviour of stone, learning how to align structures with the heavens, developing methods of transporting heavy objects, and adapting to changes in climate. This kind of knowledge doesn't need writing to exist. It can be passed from parent to child, from teacher to apprentice, across hundreds of years. If a group of people had mastered these skills and then disappeared due to environmental changes, migrations, or natural disasters, their monuments could remain while their culture faded from memory. Later, civilizations might find them, wonder at them, incorporate them into their own traditions, and build upon them. This pattern has occurred throughout history in many parts of the world. It would not be unusual for it to have happened in North Africa as well. As you turn the puzzle pieces over in your mind, you begin to notice that none of them prove anything on their own. No single fact or observation confirms an older age for the pyramids. But taken together, they create an opening. A small one, but just wide enough to let through a question. And questions are often the first signs of understanding something more deeply. You may also notice that the deeper you look into this puzzle, the more you realise how fragile our sense of the past really is. How easily our beliefs about it can shift with new evidence. How many assumptions we rely on without realising it. And how many discoveries are still waiting beneath the sand, beneath the layers of human interpretation, beneath the stories we've already written. This sense of possibility doesn't need to lead to sensational claims. It only needs to remind us that the past is larger, older, and more complex than our current maps can show, that structures like the pyramids might hold histories invisible to us for now, and that each stone, each corner, each layer of erosion carries its own quiet clue. As you sit with these thoughts, the puzzle becomes less about proving something and more about listening. Listening to what the stones might be saying, even if faintly. Listening to the questions that rise when the standard narrative doesn't feel complete. Listening to the idea that human history might be deeper than we imagine. And from here we can continue following the trail of questions without needing to solve everything at once. The puzzle buried beneath the sand doesn't demand a final answer. It just asks us to keep looking. When you start thinking about the deep past, there comes a moment when the lines that usually feel so clear begin to soften. Not in a confusing way, and not in a way that makes you feel lost, but in the same way the horizon blurs a little when the air is warm and the light is low. You can still see the landscape, but the sharp edges give way to gentler shapes. History begins to look less like a straight, certain path, and more like something textured and layered, something that took shape over countless generations rather than appearing all at once. This is where the story of the pyramids, and the questions surrounding their age, becomes even more interesting. Most timelines we learn in school feel solid. They begin at a specific year, move steadily forward, and give the impression that events happened neatly, one after another, with little overlap or uncertainty. But of course, the real world is rarely that simple. Moments don't wait in line. Cultures grow and fade. Knowledge is gained and lost. One society rises as another declines, and sometimes the record of one becomes the foundation for the other. When you look closely, the past begins to resemble a long, complicated conversation rather than a clean narrative. This becomes especially clear when you examine the earliest periods of human civilization. Even the phrase, earlier civilization, assumes something that isn't entirely accurate. It assumes that there was a single moment when humanity stepped out of prehistory and into history, as if someone somewhere flipped a switch, invented writing, and told everyone else the news. But what actually happened was far more gradual. People developed tools, shared skills, built structures, raised crops, traded and adapted to their environments for tens of thousands of years before writing ever appeared. Writing didn't create civilization. It only recorded the parts of it that left behind a script, and that's the heart of the blur. Written records give us clear lines to follow, but anything that existed before writing is pieced together from fragments. Archaeologists rely on bones, tools, pottery, seeds, pollen, charcoal, carvings, and the stubborn stones that refuse to crumble. From this, they attempt to create a picture of what life was like. And while the picture is sometimes vivid, many parts are still missing. Some areas feel detailed and familiar, others feel like faint outlines, and some feel like stretches of time we can sense but can't fully see. This is where the pyramids and the possibility of an earlier age find their place. Not in the part of the timeline we're certain about, but in the grey areas just beyond it, the areas where evidence is scarce, the areas where a discovery in one direction might reveal a piece of something much older in another. These blurred edges of history are not mistakes in our understanding. They are reminders of how much more there is to learn. One reason history begins to blur is because the Earth is an impatient archivist. It doesn't preserve most of what humans make. Wood rots, cloth decays, leather breaks apart, even simple structures collapse under storms, soil movements, and shifting climates. If a culture didn't build with massive stones, the chances of its building surviving more than a few thousand years are slim. Even the foundations could vanish under rising sands or dense vegetation. This means that the absence of older stone structures doesn't tell us that advanced building never existed. It only tells us that stone is stubborn enough to endure where other materials are not. Some of the earliest cities ever discovered were hidden under layers of mud or blown sand for thousands of years. Others remain buried today, revealed only by hints seen from satellites or through accidental finds. Every time a previously unknown site is unearthed, the timeline shifts slightly. Sometimes it shifts by a few centuries, other times by several thousand years. Each discovery deepens the blur, not in a way that obscures the past, but in a way that expands it. Consider the sudden appearance of Göbekli Tepe, a site that pushed the origins of large-scale stone construction far earlier than scholars expected. It wasn't supposed to exist according to the older timelines. It suggested that people were building monumental structures before the rise of settled farming communities, something that challenged long-held assumptions. The discovery didn't rewrite history in one stroke, but it nudged the edges of the timeline and showed that the past could be far more surprising than we assumed. It demonstrated that humans were capable of organised projects long before written history began. This kind of shift helps explain why history blurs. When discoveries move boundaries, they reveal how little we truly know about the full extent of human achievement. They also show that what we think of as early or late in history is often based on limited evidence. When the evidence grows, the story changes. Not abruptly, not dramatically, but steadily, like a shoreline eroding or a glacier revealing something long hidden beneath ice. Another reason history blurs is because many ancient cultures shared ideas without leaving a clear record of who developed what first. Knowledge travels easily, even without writing. People migrate, they trade, they observe and imitate. Skills spread through contact, through necessity, and through the slow passing of generations. If one culture figured out a technique for cutting stone, aligning structures, or navigating by the stars, that technique could spread over vast distances long before a single word was written. This makes it difficult to pinpoint the exact beginning of many skills. When archaeologists find a complex tool in one place and a similar tool thousands of miles away from the same era, it doesn't always tell them which group invented it. It tells them the knowledge existed, but not necessarily where it started. And when you try to trace the origin of something through scattered evidence, the edges naturally blur. Historians become cautious and avoid making claims that stretch too far, but the underlying truth remains. Knowledge has always flowed more freely than our records show. This brings us back to the pyramids. If the skills required to build such structures existed earlier than we currently believe, the evidence for that earlier knowledge might not have survived. It could be buried beneath meters of sand, submerged beneath rising coastlines, or eroded away by time. The pyramids may not mark the beginning of monumental building in stone, but could instead reflect the continuation of skills that began in places or structures we haven't yet discovered. Nowhere is the blur more visible than in the transitions between major historical periods. When one culture ends and another begins, we often imagine a clean break. But most transitions are slow and messy. Knowledge carries over. Old techniques continue. New ideas grow out of older ones. When you look at timelines across continents, you see overlapping centuries where multiple cultures coexisted, influenced one another, and evolved in parallel. It becomes difficult to say exactly when one era ended and another began. The lines between them aren't sharp. They fade gently, like dusk blending into evening. Even in well-documented eras, this blur is noticeable. For example, ancient texts might describe an event one way, while archaeological evidence suggests something slightly different. Historians then work to reconcile both sources, but they rarely produce a single definitive explanation. Instead, they outline multiple possibilities. They provide ranges of dates instead of exact years. They describe cultures as dynamic rather than fixed. These uncertainties aren't flaws. They're the natural outcome of trying to reconstruct the past from incomplete information. When you apply this understanding to the pyramids, the timeline becomes less rigid. The idea that they were built at a specific moment in a specific century becomes more flexible. It becomes possible to imagine that the culture responsible for them inherited knowledge from earlier groups, or that the structures themselves had earlier phases of construction or foundation work that predated the final form we see today, or that humans living long before the traditional date achieved things we haven't yet uncovered. This doesn't require imagining anything extreme. It only requires acknowledging that our picture of the past is partial, that we're standing at the edge of a vast landscape but can only see as far as the surviving evidence allows. If the past is a tapestry, we're holding a fragment, not the whole, and that fragment may hint at patterns that extend beyond its borders. Another area where history blurs is in the interpretation of oral traditions. Many ancient cultures passed knowledge down through stories rather than writing. These stories often mix real events with symbolic elements, making them difficult to interpret. But buried within them are sometimes clues about environmental changes, migrations, or encounters with older structures. Some stories describe floods that align with geological evidence. Others mention lands that have since disappeared. Others refer to structures or knowledge that don't fit neatly into the accepted timeline. While oral traditions aren't scientific evidence, they are part of the human record. When multiple unrelated cultures share similar stories, it invites consideration of whether these stories preserve memories from a time before writing. Archaeology is cautious with oral traditions, as it should be. But the existence of blurred stories from different cultures serves as another reminder that history is not as straightforward as it appears. It's composed of layers of memory, both written and unwritten, both preserved and forgotten. Some layers are sharp, others are soft, and when the soft layers overlap they form a blur. This blur also appears when we look at the broader environment of the ancient world. Climate has shifted many times over the last 20,000 years. The Sahara has alternated between lush grasslands and harsh desert. Rivers have changed course. Coastlines have shifted dramatically. Many ancient settlements that existed during wetter periods are now buried beneath desert dunes. Others that once sat safely inland are now underwater. These changes erase evidence. They hide entire chapters of human activity. They turn thriving regions into places difficult to study. If there were cultures capable of significant construction or organisation during these forgotten periods, their remains might only survive in places where stone was used heavily and erosion was minimal. The pyramids, being made of stone and located on ground stable enough to endure shifting climates, may simply be survivors of a larger story rather than isolated achievements. Their endurance might reflect not their position at the beginning of human civilization, but their position in an environment less vulnerable to decay. The more you examine these overlapping ideas, the more you understand why history begins to blur. Not because scholars are uncertain, or because evidence is lacking, but because the past is vast and complex. Different threads of human experience blend together, different timelines overlap, different cultures rise at different speeds, leaving behind uneven records. When we try to draw straight lines through this complexity, the lines inevitably soften at the edges. What's interesting is that this blur doesn't weaken our understanding of the past. It deepens it. It reminds us that human history is not confined to the narrow slice recorded in writing. It stretches back through countless generations of people who lived, worked, built, and observed the world in ways we may never fully recover. It reminds us that the absence of surviving evidence does not mean the absence of achievement. It simply reflects the passage of time and the fragility of human creations. When you apply this understanding to the question of the pyramids, the timeline becomes open rather than fixed. The structures stand as anchors in a sea of possibilities, pointing to skills that may have deeper origins. They invite us to consider that the beginning of organised construction might lie farther back in time, that the version of history we learn is shaped by what has survived rather than by everything that once existed. And when you look at the pyramids again with this in mind, they seem a little different. Not less impressive, but more mysterious. Not isolated achievements, but possible echoes of something older. Not the starting point of monumental architecture, but perhaps one of its middle chapters, built upon knowledge that originated in periods we haven't yet uncovered. As you let these ideas settle, the past becomes a place with wider horizons. A place where blurred lines aren't obstacles but opportunities to expand our understanding. A place where discoveries still wait beneath sand and stone, and where every new find has the potential to shift the timeline gently, revealing more of the story. When you begin exploring the possibility that the pyramids might connect to something older than the civilization we usually place them in, one of the first realizations that settles in is how much of the ancient world still lies beyond our reach. Not in a mysterious or supernatural way, but simply because so much time has passed. The Earth has changed, landscapes have shifted, weather patterns have transformed entire regions, human settlements that once held life, voices, traditions, and knowledge now sit buried beneath sediment, sand, ocean floors, or collapsed layers of soil that have piled up over tens of thousands of years. Most of what came before the earliest known cities has disappeared, leaving only faint indications that people lived, created, and understood more than we often give them credit for. When you stand in front of the pyramids, even just in your imagination, it's easy to feel that sense of distance. It isn't just the age of the stones that creates it. It's the awareness that these structures don't just represent a single moment in time. They exist at the crossroads of countless earlier lives, earlier experiments, earlier attempts to shape the world in ways that are no longer visible. The pyramids become a reminder that the visible traces of human history are only a small part of a much larger continuum. To understand what might have preceded them, you don't have to imagine anything extraordinary. You only have to look at the evidence that humanity has been present on this planet long before the rise of the earlier cities. People walked, hunted, built shelters, navigated coastlines, created tools, carved symbols, and adapted to their surroundings for far longer than the period we call civilization. Tens of thousands of years, and in some places even more. During that time, entire regions would have supported communities capable of sharing knowledge, building traditions and developing skills that could be passed down from generation to generation. It's easy to forget how long a single 1,000 years actually is. Multiply that by several tens, and you begin to grasp how much could have unfolded in the deep past without leaving behind the kind of monuments we recognize today. In some parts of the world, traces of this older activity appear as scattered tools or carved stones. In others, small fragments of dwellings or hearths hint at the presence of communities now erased by erosion or buried deep underground. These fragments don't tell full stories, but they show that humans have been shaping their environment for far longer than written records reveal. And while most cultures left behind only short-lived materials that have since vanished, it is not unreasonable to consider that some groups may have experimented with stone earlier than we currently know. The world they lived in was different from the one we see now. During the last ice age, sea levels were dramatically lower. Entire coastlines extended far beyond their current boundaries. Areas now underwater may once have held communities, trade networks, and gathering sites that played a crucial role in the development of early human societies. When the ice melted and sea levels rose, many of these places were submerged. If any early stone structures existed along those ancient coastlines, they could now be inaccessible to archaeologists, hidden beneath hundreds of feet of water. Some submerged locations have been found, revealing surprisingly advanced settlements that challenge older assumptions about when complex societies began to form. In certain regions, underwater structures, roads, or foundations have been discovered that appear older than expected. These finds don't overturn established timelines, but they do add layers to them, showing that human activity was more widespread than once believed. Each new discovery becomes an echo from a world that disappeared beneath rising seas, reminding us how incomplete our picture of early humanity really is. The deserts tell their own version of this story. In places that now seem barren and inhospitable, scientists have found evidence of ancient lakes, rivers, and fertile landscapes. The Sahara, for example, once supported lush vegetation, abundant wildlife, and human communities who left behind rock art depicting scenes of daily life. These drawings show animals and environments that have not existed in the region for thousands of years. They offer glimpses into a vanished world, a world that might have nurtured cultures capable of passing down knowledge that could later influence the builders of the pyramids, even if indirectly. When you look at this broader picture, the idea of forgotten worlds becomes less like a speculation and more like an acknowledgement of what time does. Civilizations rise not only in fertile river valleys, but also in places that later become deserts. They grow where coastlines once existed and later sink beneath rising oceans. They develop in environments that no longer resemble their ancient forms. Their stories may have been preserved in memory for a while, or passed down through oral traditions, but eventually even those traces fade. What remains are only hints, half buried in eroded layers, or concealed in landscapes transformed by climate. Some of these ancient hints puzzle archaeologists because they don't fit neatly into the expected timeline. A tool appears too advanced for its era. A piece of stone architecture seems unexpectedly precise. A carved symbol suggests knowledge of astronomy long before written evidence supports it. These anomalies are not proof of anything dramatic. They are simply reminders that the earliest parts of human history are poorly documented, not because nothing was happening, but because the evidence didn't survive. When you consider all of this together, the possibility that knowledge from older cultures could have filtered into later societies becomes more reasonable. Human beings have always shared information. Skills passed between groups through trade, migration, marriage, conflict, imitation, and simple observation. A technique that appears sudden in the archaeological record may have much older roots and traditions that didn't leave behind durable remains. A structural concept might have been taught verbally for generations before someone finally carved it into stone, and once a culture begins building in stone, the durability of their work gives it a chance to survive into the distant future, long after other traces of their world have vanished. This is where the echoes become important. They don't tell complete stories. They don't explain exactly who built what or when. Instead, they suggest continuity of knowledge across long stretches of time, across shifting landscapes, and across the rise and fall of countless human groups whose names we'll never know. When a structure appears fully developed in a later civilization, it may reflect a tradition that began elsewhere, in some forgotten settlement or lost community that never built a monument sturdy enough to endure. The fact that so many ancient cultures developed similar architectural forms reinforces this idea. Pyramidal shapes, megalithic stones, astronomical alignments, and precise geometry appear in environments separated by vast distances. These similarities don't imply a single origin or a unified ancient world. They simply show that human beings everywhere were curious about the sky, invested in stability, and capable of developing impressive techniques. But if those techniques existed long before the cultures that recorded them, then their origins lie in places now erased by time. Sometimes the only evidence we have of older worlds comes from the landscapes themselves. Fossilized riverbeds, mineral deposits, pollen layers, and patterns of erosion reveal climates that supported life in ways no longer visible. If an early community lived near a river that dried up or moved, their remains might be far from where archaeologists expect to find them. If they built temporary structures, those would be gone within centuries. Only the hardest stones or the deepest carvings would remain, and even those might be worn beyond recognition. In this sense, the pyramids and other long-standing structures act like anchors in time. They survive because they were built from materials strong enough to withstand thousands of years of wind, sand, and sun. These surviving structures naturally dominate our view of the past because they are still here, but they don't necessarily represent the first experiments in monumental architecture. They represent the examples durable enough to endure. Behind them and beneath them, and far beyond them in older landscapes, there may have been earlier attempts that left no trace. The idea of forgotten worlds doesn't rely on imagining anything unusual. It relies on understanding how much can vanish in the span of 10,000 years. Forests turn into plains, plains turn into deserts, lakes dry up, dry riverbeds become covered in dunes, volcanic eruptions bury villages in ash, ocean currents shift, flooding some coastlines and exposing others. Over these long spans, human structures made of wood, clay, reeds, or simple stone crumble into dust indistinguishable from the surrounding soil. Only the largest, most carefully constructed monuments have a chance of surviving. This awareness changes how we interpret what remains. When you see a structure as impressive as the pyramids, you start to notice how much of the story feels missing. You feel that absence not because the structure is incomplete, but because the history surrounding it has been swept away. These monuments are like voices carried across a long distance, faint but still recognizable. What they're saying isn't clear. They speak without words, but the fact that they are still here means the culture responsible for them reached a level of organization that didn't arise overnight. The echoes from forgotten worlds also appear in the distribution of ancient knowledge. In several parts of the world, early people understood how to observe stars with surprising accuracy. They tracked seasons, predicted solstices, and aligned structures with celestial events. These skills don't require advanced technology, but they do require patience, long-term observation, and intergenerational teaching. That kind of knowledge usually emerges from societies with enough stability to focus on tasks beyond daily survival. If similar knowledge appears in multiple regions older than expected, it suggests the existence of early communities that valued observation and structure even if they didn't leave behind enduring monuments. You can see this pattern in the earlier surviving artwork. Cave paintings reveal detailed understanding of animals, movement, and environmental patterns. Some interpret certain paintings as early forms of symbolic expression or record keeping. Even if that interpretation is debated, the detail in the artwork suggests cultures capable of careful observation and long-term skill. If people tens of thousands of years ago were capable of producing intricate artwork, it's not far-fetched to imagine them also experimenting with shaping stone or building more permanent shelters when the environment allowed. The challenge is that climate often determines what survives. In wet regions, even stone can be eroded beyond recognition. In freezing regions, ice can split rock apart. In humid regions, plant roots can infiltrate structures until they collapse. Only in certain dry, stable environments do stone structures endure for tens of thousands of years. This makes it difficult to determine where early building traditions may have begun. The places that were once ideal for settlement may no longer exist in the same form, while places that were once marginal could now be the preserve of the oldest surviving monuments. When you look at this patchwork of incomplete evidence, it becomes easier to understand why history blurs as we move deeper into the past. The record relies heavily on what survived rather than what existed. The picture we build is constrained by climate, geography, and preservation. And when we find a structure like the pyramids that seems to leap above its time, it may reflect the survival of a tradition that belonged to a world now largely erased. The echoes also take the form of questions left by early structures in other regions. Megalithic sites scattered across Europe, Asia, and the Americas suggest that organized construction was more widespread than we once believed. Some of these sites predate the pyramids by thousands of years. Others appear in later eras but use techniques that seem older. When these different sites are viewed together, they hint at a long and varied history of experimentation with stone, alignment, and monumental form. These echoes reveal that human ingenuity expressed itself in many places long before the full timeline was understood. Another layer of forgotten worlds comes from genetic evidence. Studies of ancient human DNA show waves of migration, intermixing, and cultural exchange across continents. These movements often occurred during periods for which we have no written records and limited archaeological data. Entire populations moved through regions where their material culture did not survive, yet their genes appear in later groups, showing that their existence is part of the human story, even if their buildings, symbols, and traditions did not endure. In these migrations, knowledge would have moved as well, carried by travellers who encountered other groups and exchanged ideas. This creates a continuous thread of influence across long periods that may never be fully documented. All of these factors contribute to the idea that the world before the rise of known civilizations was not empty or simple. It was populated, diverse, and dynamic. It held groups capable of observation, planning, tool-making, exploration, and perhaps even early monument building in ways that have not survived. When you look at the pyramids through this wider lens, they become part of a larger human story rather than isolated achievements. The past begins to feel broader and deeper, not mysterious in a way that suggests anything impossible, but rich in ways that emphasize how much remains hidden. The echoes from forgotten worlds aren't loud. They're subtle. They appear in rock carvings, submerged foundations, eroded stones, unexpected tools, and genetic traces. Together they suggest that human history extends further than our surviving records show. They invite us to consider that the knowledge used to build the pyramids might not have originated only in the era to which they are attributed, but may have roots stretching back into landscapes and cultures we have barely begun to uncover. Sorting through the distant past often feels less like opening a neatly organised archive, and more like trying to rebuild a vast structure from only a handful of stones. Not elegant stones with inscriptions or clear markings, but worn pieces whose edges have softened under thousands of years of weather. Archaeologists and historians know this challenge well. Every discovery is valuable, but each one represents only a tiny fraction of what once existed. The work of reconstructing early human history relies on making sense of these fragments, arranging them carefully, and trying to understand the larger shape they once belonged to. It's a slow, patient effort, and it forms the foundation for everything we think we know about where the pyramids fit on the timeline. One of the guiding principles of archaeology is that the past doesn't hand itself to us in perfect condition. It fades, mutates, collapses, and sinks into layers of soil, sediment, and sand. The people who lived thousands of years ago didn't think about what their homes, tools, or monuments would look like in the distant future. They lived within their own time, solving their own problems, leaving behind things they never expected anyone else to study. Because of that, almost all material evidence from early civilizations either decays or becomes nearly impossible to interpret. Over long periods, the Earth's surface moves. Rivers change course. Earthquakes reshape the land. Wind buries entire landscapes beneath dunes. With every passing century, more of the record becomes harder to access. Yet, despite these limitations, archaeology continues assembling an enormous puzzle out of these scattered pieces. Dating methods help, but even they come with uncertainties. Carbon dating can only measure organic materials, not stone. Stratigraphy depends on layers that sometimes shift. Tool typologies rely on finding enough items to identify patterns. Inscribed records, when they exist, provide clarity, but written language arrived late compared to the span of human existence. Most societies that lived in the earliest eras had no writing at all, so they left behind only the materials they worked with and the marks they carved into them. When you look at how archaeologists develop timelines, you begin to understand just how delicate the process is. Dates are often ranges rather than exact years, Interpretations depend on cross-referencing objects found in similar contexts. Assumptions are refined as new finds appear. For example, if a particular style of pottery is discovered in a settlement that can be dated through carbon samples, that style can then be used to date other sites where the same pottery appears. But pottery breaks easily, and styles can spread between cultures, so those connections aren't always certain. Each inference is a careful step forward, knowing that a single discovery in the future could require adjusting the entire structure of the timeline. This is not a weakness in the field. It's a reflection of how extraordinarily difficult it is to reconstruct the past when only fragments remain. What's remarkable is not how much is uncertain, but how much has been learned despite these limits. When archaeologists uncover new settlements, burial sites, tools, or structures, each one adds a little more clarity. Over time, patterns emerge. You can see when agriculture developed in different regions, when metalworking began, when people shifted from nomadic life to permanent villages. You can see how societies adapted to climate change, how trade routes formed, and how cultural practices spread. Still, there are enormous stretches of time where the evidence is thin. These stretches form the shadowy backdrop to the clearer parts of the historical record. They represent eras in which humans lived fully human lives but left little that could survive long enough for modern researchers to analyse. These gaps complicate the effort to place monumental structures like the pyramids into a definitive historical context. If earlier societies developed techniques that didn't leave behind durable evidence, those techniques would be invisible today. The timeline might appear to show a sudden leap forward in architectural capability, when in reality it might represent the surviving tip of a much older tradition. Take stoneworking, for example. The skills required to shape limestone, granite, and basalt with precision didn't develop overnight. They require experimentation, knowledge of material properties, consistent tool-making, and the ability to organise labour effectively. If early groups practiced these skills using softer stones or built structures that didn't withstand erosion, their contributions would have vanished. Only the most resilient examples from later periods would remain, giving the impression of sudden advancement. This kind of deceptive jump appears in other fields too. The earliest surviving evidence of metal smelting, early pottery, and symbolic art does not necessarily mark their actual beginnings. It only marks the earliest examples that have been found. Archaeologists regularly uncover older instances of these technologies, which pushes the timeline backward with each discovery. Another factor complicating the reconstruction of ancient timelines is that different regions developed at different speeds. Some areas supported large populations due to fertile land and stable climates, which helped societies grow more rapidly. Other regions face challenges like drought, shifting climates, or resource scarcity. In these places, technological development could stall or even regress. Because of this uneven progress, the earliest surviving monumental structures might not represent the earliest attempts at such structures globally. They might simply be the ones built in environments that allowed them to last. The Nile River Valley is a good example. Its seasonal flooding deposited fresh soil every year, supporting agriculture and helping early communities grow. This stability created favourable conditions for building permanent structures, storing grain, developing symbolic carvings, and organising large-scale labour. But other regions with earlier populations may not have had the same stability. Their achievements could have disappeared along with the environments that supported them. When archaeologists examine sites like Göbekli Tepe or ancient settlements in the Near East, they often find levels of complexity unexpected for their age. These discoveries challenge the assumption that civilization always evolves in a straight line. Instead, they reveal bursts of creativity and organisation that don't neatly align with earlier timelines. This is a significant reminder that the past was full of dynamic changes, not a slow, predictable rise. It was shaped by experimentation, adaptation, migration, and environmental shifts. The reconstruction of history also involves interpreting the intentions behind structures, tools or symbols. When the surviving evidence is minimal, these interpretations become even more challenging. A single stone circle might be a ceremonial site, a calendar, a gathering place, or something entirely different. Without written explanations or surviving oral traditions, archaeologists must infer meaning from position, alignment, and context. This creates room for debate, which is healthy and expected, but it also highlights how fragile our conclusions can be when built on limited data. In the case of the pyramids, the context includes inscriptions from later periods, burial practices associated with pharaohs, and connections to religious beliefs. These provide a framework for understanding the pyramids within the Old Kingdom of Egypt. But this framework doesn't entirely rule out the possibility that earlier knowledge contributed to their construction. If cultural memory from earlier societies influenced the builders, or if they inherited traditions from older groups, this would fit comfortably within what we know about the diffusion of ancient knowledge. Reconstructing the past also involves studying the tools found at archaeological sites. In Egypt, copper chisels, dolerite pounding stones, and other implements associated with construction have been discovered. These tools demonstrate that ancient workers had the means to shape stone effectively, but the surviving examples don't represent the full range of their methods. Organic components like wooden levers, ropes, scaffolding, or primitive pulleys rarely survive across millennia. If more complex systems were used, still simple by modern standards but sophisticated for their time, they could easily have vanished. Because so much is missing, archaeologists remain cautious about definitive statements. They must balance imagination with evidence, avoiding speculation while remaining open to new possibilities. In many ways, reconstructing the past resembles reconstructing a vase from a few remaining shards. You can see the curvature, the texture, the material, and the craftsmanship, but large parts of the design are lost. Experts do their best to estimate the missing pieces, using knowledge from similar finds, comparisons to other cultures, and the physical properties of what remains. This work becomes even more challenging when dealing with periods that lack comparative examples. If the pyramids represent the earliest surviving examples of their type, then we have little context to understand how such construction evolved. It would be similar to finding a fully developed modern bridge without finding any earlier models of smaller bridges or support structures. In that situation, it's natural to wonder whether earlier examples existed but did not survive. It's not an attempt to rewrite history dramatically. It's simply acknowledging that surviving stone monuments represent only a narrow slice of the ancient world. The reconstruction of the past is also shaped by the fact that archaeological discoveries depend on chance. A site might remain buried for thousands of years until a road construction project uncovers it. A desert might shift, revealing the corner of a long-lost settlement. A farmer might stumble upon a carved stone while digging in a field. These moments of chance create ripples that slowly reshape the larger timeline. When a single discovery can adjust centuries of accepted thought, it becomes clear how incomplete the record is. In recent decades, satellite imaging, ground-penetrating radar, and other technologies have revealed hidden structures and patterns across landscapes previously assumed to be empty. Networks of ancient roads, foundations of forgotten settlements, and previously unknown ceremonial sites have been discovered this way. These findings demonstrate that our understanding of the ancient world continues to grow as new tools allow us to see beneath the surface. Many regions that seemed barren now show signs of extensive human activity. These discoveries contribute to the unfolding reconstruction of the past, revealing how much was once hidden and how quickly assumptions can shift. Another dimension of this reconstruction is the role of climate science. Ice cores, sediment layers, and pollen samples show how dramatically the Earth's environment has changed over time. Periods of abundant rainfall gave way to droughts, lakes dried up, forests expanded and retreated. Each of these shifts would have reshaped where people lived, how they survived, and what structures they built. If early communities constructed monumental structures during wet periods in regions that later became uninhabitable, The remains of those structures might now lie buried in deep desert or beneath layers of later sediment. Understanding these environmental changes helps archaeologists identify where ancient sites might be hidden, and explains why some regions show long gaps in the archaeological record. Through all of this, the reconstruction of history is a careful balance between what is known and what is missing. Archaeologists rely on evidence but must constantly revise their understanding as new information appears. This process is cumulative. Each discovery adds a small piece to the larger picture. Even so, the picture will always be incomplete. The earliest eras of human activity left behind little that can survive to the present. That doesn't mean people were less capable or less organised. It means only that the physical traces of their lives have not endured. When you apply this understanding to the pyramids, it becomes easier to see why questions arise about their place in history. They appear suddenly in the surviving record as enormous, precise structures. They challenge assumptions about how quickly technological and organisational complexity can develop. They stand in a region where earlier evidence may have been erased by climate changes, floods, or the shifting sands of the desert. They are surrounded by landscapes that once supported thriving communities now lost to time, and they represent skills, surveying, geometry, stoneworking, labour coordination, that could have roots in older practices that no longer exist in physical form. None of this suggests anything outlandish. It simply highlights the limitations of our current knowledge. It suggests that the reconstruction of the past is ongoing, not complete. It invites us to remain open to the idea that early humans may have developed skills earlier than we currently recognise, and it helps explain why some researchers consider the possibility that the pyramids could reflect traditions inherited from much older cultures. You start to appreciate how fluid the study of ancient history really is. It isn't fixed or rigid. It evolves as more of the past is carefully uncovered. The reconstruction of human history requires humility, patience, and a willingness to adjust earlier conclusions. This process is not about proving a specific narrative. It's about understanding the complexity of how humans lived, created, and built over vast stretches of time. Looking at the pyramids through the lens of geology offers a perspective many people never consider at first. When most of us think about stone, we imagine something fixed and permanent, something that doesn't change unless a person cuts into it. But stone has its own relationship with time. It records the past in ways that are subtle but measurable, absorbing the effects of wind, water, temperature, pressure, and the long cycles of climate that unfold over thousands of years. In this way, stone becomes a kind of clock that ticks so slowly we only notice its movement when we compare the present to a much earlier moment. When researchers study the pyramids and other ancient structures, they often turn to these geological clocks to understand not just how the stones were shaped, but how long they have been exposed to the elements. One of the first geological clues that invites closer attention is erosion. Stone erodes in predictable ways depending on the climate around it. The intensity of rain, the dryness of the air, the temperature swings between day and night, and the presence of wind-blown sand all influence the patterns carved into its surface. When studying ancient monuments, geologists examine the depth of these patterns to estimate how long the surfaces have been exposed. This kind of analysis is not exact, but it provides a general sense of timelines. If a stone structure shows more erosion than expected for its assigned age, researchers begin asking questions. This is part of what fuels ongoing debates about structures on the Giza Plateau. While many archaeologists are confident about the traditional dating, some geologists believe the erosion they see tells a different story. Their observations often focus not on the pyramids directly, but on nearby structures such as the Sphinx and the surrounding walls carved from the bedrock. These features, according to some interpretations, show patterns of wear that resemble the effects of sustained, heavy rainfall. The interesting part is that this kind of rainfall hasn't occurred in the region during the known era of the pharaohs. It belongs to a much earlier period when Egypt's climate looked very different. If these erosion patterns do reflect older, wetter conditions, then the stone surfaces in question may have been exposed long before the traditionally accepted timeline. This doesn't automatically mean the pyramids themselves are older, but it opens a door to revisiting the environmental history of the region. It suggests that the landscape around Giza has seen dramatic climate changes over long cycles, and that structures built during or before those changes might show signs of exposure that don't match the established chronology. To understand how significant this is, it helps to picture what the region once looked like. Thousands of years before the dynastic period of Egypt, North Africa experienced heavy rainfall, flowing rivers, grazing animals, and widespread vegetation. The land that is now dry desert supported large populations of wildlife and possibly early human settlements. Rivers carved channels into bedrock. Rain soaked into limestone cliffs. Wind pushed clouds over green plains. If structures or natural surfaces were exposed during this earlier period, they would bear a different pattern of erosion than surfaces first exposed during the much drier era that came later. Geologists who support earlier timelines argue that the vertical and rounded erosion on certain parts of the plateau look consistent with long-term exposure to rainfall rather than wind erosion alone. Wind erosion tends to produce sharper, more angular patterns. Rainfall, on the other hand, creates smoother, more rounded channels over long periods. When you look at the weathering on certain ancient surfaces in Egypt, some researchers see characteristics that seem to match the rainfall pattern. This is where geology becomes important. The stone isn't simply damaged, it records the climate that shaped it. Another geological clock embedded in the pyramids involves the variety of limestone used. The stones that form the core of the pyramids come from local quarries and contain fossils from ancient marine life. These fossils give a sense of the geological age of the stone itself, which is measured in millions of years. But what matters for archaeology is not the age of the rock, but the age of the surface exposure. When a block is newly quarried, the fossil patterns appear fresh. Over time, exposure to the environment alters their appearance. Layers of salt build up, chemical weathering, and microfracturing occur slowly, and these processes leave behind marks that geologists can analyse to estimate how long the stone has been out in the open. These methods don't yield precise dates, but they offer clues. Sometimes the clues agree with traditional archaeology. Other times they raise questions. For example, on some blocks found at certain sites, the weathering seems more advanced than expected for structures believed to be a few thousand years old. Researchers who notice this discrepancy look for explanations. They might suggest older exposure. They might propose that some stones were reused from earlier structures. They might consider changes in climate. Each possibility becomes part of the broader puzzle of reconstructing the past. Even the cracks in the stones have stories to tell. Natural fractures that develop over long periods can reveal patterns of stress caused by earthquakes, temperature changes, or shifts in the foundation beneath the structure. By studying these fractures, geologists can get a sense of how long the stone has been sitting in its present position. This kind of analysis has been applied to many ancient monuments around the world. Sometimes it supports established timelines. Other times it suggests that certain blocks were placed earlier than expected, or endured environmental conditions not associated with their assumed era. Another factor is the accumulation of patina on stone surfaces. Patina is a thin layer of chemical alteration that forms as stone interacts with the air, water vapour, and minerals carried by wind. In desert environments, this layer forms slowly, influenced by temperature fluctuations and the presence of airborne dust. The thickness and composition of patina can be measured and used to estimate exposure time. If two nearby structures have significantly different patina layers, it might indicate that one is considerably older, or that one underwent restoration or reworking in the past. For the pyramids, patina studies have produced mixed results. Some sections appear consistent with the expected age. Others show signs of older exposure or unusual patterns that don't match the dry climate of the last several thousand years. These inconsistencies prompt further investigation. Geologists might ask whether certain regions of the structure were exposed earlier than others. Perhaps some blocks were repurposed from older sites. Or perhaps the structure underwent phases of exposure and burial, influenced by sand accumulation or environmental cycles. None of these explanations are definitive, but they illustrate how stone preserves traces of its own history that differ from human records. The surrounding bedrock of the Giza Plateau also plays a role in this reconstruction. The plateau consists of layers of limestone that vary in hardness and fossil content. These layers erode differently depending on their composition. By studying how these natural layers have weathered over time, geologists can establish baseline erosion rates for the region. When a carved surface or cut block shows erosion that significantly exceeds or differs from the baseline, it raises questions about its age or its exposure history. Some researchers point to the deep channels cut into bedrock walls near the Sphinx enclosure as an example. These channels appear rounded and smoothed in ways that resemble the effects of prolonged rainfall rather than the abrasive action of sand-laden winds. Since the region has been arid for much of the last 5,000 years, this type of weathering suggests exposure during an earlier period of heavier rain. If this interpretation is correct, the surface might be older than the structure traditionally associated with it. Whether this older surface was part of an earlier phase of construction, or simply a natural surface later incorporated into the site, is part of what makes the geological evidence compelling. Beyond erosion, sediment deposits offer another way to understand past environments. Layers of sand, silt, and dust accumulate over time and can be trapped in cracks or sheltered areas of stone structures. By analysing these deposits, researchers can infer what the environment was like at different stages of the structure's history. For example, if a layer of sediment contains pollen from plant species that no longer grow in the region, it suggests that the climate was once more hospitable. Such findings, although subtle, contribute to a larger understanding of the ancient landscape. It's also worth considering that the pyramids and their surrounding structures have undergone countless cycles of burial and exposure over thousands of years. Windblown sand can accumulate quickly, covering lower structures almost entirely. Later, shifting winds or human excavation can remove the sand, exposing surfaces that may have been protected for centuries. This uneven exposure complicates geological dating. A stone face buried under sand for most of its history will show much less erosion than a face exposed to the open air. When these differences appear within the same structure, geologists must interpret them carefully. They must consider how shifting sands shaped the exposure history of each surface. Another form of natural record-keeping appears in the tiny crystals inside limestone. These crystals expand and contract with changes in temperature. Over long periods, this creates microscopic stress patterns within the stone. By studying these patterns under magnification, geologists can sometimes detect how long the stone has been exposed to temperature cycles. This technique is still evolving, but it represents another way stone can act as a recorder of time. Then there are the dissolved minerals carried by groundwater. In regions where water flows through rock, minerals can deposit thin layers on stone surfaces. These layers, called mineral crusts, form slowly and can be dated through techniques such as uranium-thorium analysis. By examining these crusts on ancient structures, researchers can estimate when certain surfaces were last exposed or altered. In some cases, mineral crusts found on carved surfaces suggest ages that precede the periods usually associated with known civilizations. These findings are subject to debate, but they show how geological evidence can sometimes challenge established views. One reason these geological clocks matter so much is that they operate independently of human interpretation. They don't rely on inscriptions, historical records, or cultural context. They rely on the physical properties of stone and the natural processes that affect it. This independence makes geology a valuable tool for cross-checking archaeological assumptions. When geological evidence aligns with established timelines, it reinforces confidence in them. When it diverges, it prompts deeper investigation. In the case of the pyramids, the The geological evidence doesn't produce a simple answer. Different surfaces show different patterns. Some align with the expected age. Others appear older or shaped by environments that existed thousands of years earlier. These discrepancies don't prove anything conclusive about the construction date, but they create space for questions. They invite us to consider that the structures may have complex histories involving multiple phases of construction, environmental changes, or earlier foundations that later builders incorporated. Geological clocks also remind us that ancient people interacted with stone at many different times and in many different ways. A quarry used in one era might have been reused in another. Blocks carved centuries earlier might have been repurposed in later construction. Natural formations might have been reshaped by human hands. Each interaction leaves traces in the stone, traces that geologists can sometimes detect even when human records are silent. For example, when quarry marks reappear under more recent tool marks, or when older weathered surfaces sit beside newer cuts, it suggests reuse. In some cases, structures that look cohesive at first glance reveal a patchwork of stone with different histories. This kind of complexity is not unusual. Many ancient monuments around the world show signs of rebuilding, expansion, or modification over long periods. The pyramids may be no exception. Geological evidence could help reveal which parts were shaped at the same time and which might reflect earlier work. These considerations bring us back to the fundamental question of how to interpret the geological clocks embedded in the pyramids and surrounding structures. The stone doesn't speak with a single voice. It preserves many overlapping timelines: natural exposure, human use, environmental cycles, and restoration efforts. Making sense of these timelines requires careful analysis and an understanding that geology alone cannot provide definitive answers about construction dates. Instead, it offers a parallel record that complements archaeological evidence and helps build a more complete picture. What geology reveals most clearly is that the landscape in which the pyramids stand has changed dramatically over long periods. Rainfall patterns, sand accumulation, groundwater flow, and climate shifts have all shaped the stone. These changes suggest that earlier environments may have supported activity not recorded in written history. If earlier cultures lived in the region during wetter periods and interacted with the stone, the geological record might preserve traces of their presence, even if their tools, homes, and artifacts did not survive. This perspective doesn't replace the established timeline. It expands the context around it. It shows that the region's history is layered, not simple. It suggests that the pyramids may stand within a landscape that saw human activity far older than the structures themselves, and it provides a foundation for understanding why some researchers consider the possibility that certain skills or traditions used in pyramid construction could have originated in earlier periods. As you follow these ideas, the stone begins to feel less like a static material and more like a slow observer. It absorbs the passing of time, captures the imprint of climate, and holds on to traces of every hand that shaped it. The geological clocks hidden within the pyramids may not tell us exactly when they were built, but they offer clues about the world that existed before them and the long story of natural and human forces that shaped the landscape. Across many distant regions of the world, from deserts to jungles to high plains shaped by seasons of wind, one particular architectural form appears again and again with a consistency that draws attention the moment you step back far enough to see the pattern. It doesn't matter whether you're looking at massive stone monuments or smaller earth mounds. It doesn't matter whether the structure comes from a culture with writing or one that left no written record at all. Over and over, the same general shape returns. The shape that narrows as it rises. The shape that stands wide at the base and converges toward a single point. The shape that resists collapse more effectively than nearly any other. The shape that seems to appear instinctively across human history, even when cultures had no contact with one another. The pyramid. Understanding why this form shows up so consistently requires looking beyond specific civilizations and considering the practical realities faced by early builders everywhere. Stone is heavy, earth shifts, weather wears away surfaces, simple structures collapse easily without supports, but a shape that distributes weight downward and outward can endure enormous pressure. Whether built from stone blocks, mud bricks, packed earth, or piled rubble, the pyramid form stabilizes itself. If a culture wants to build tall before it has advanced engineering tools, this is the most forgiving shape available. That alone explains much of why it appears around the world. Yet, there's more to this shape than structural stability. Early people often wanted to create something that felt connected to the sky, something that rose above daily life. They wanted to build platforms for rituals, burial chambers, markers of territory, or expressions of symbolic meaning. When the desire to elevate is combined with limited tools, the pyramid becomes an obvious solution. It is the simplest way to move upward without the risk of collapse. In this sense, the shape doesn't just defy time, it bridges the gap between practical needs and human imagination. But when you stand before the Great Pyramid of Giza, or one of its smaller companions, the simplicity of the form feels misleading. The closer you get, the less the structure resembles universal instinct, and the more it resembles a precise, deliberate creation. The angle of each side is carefully chosen, the alignment is intentional, the scale is beyond anything required for mere stability. The structure seems designed not only to last but to communicate something, even if that message is no longer understood. Examining why this form became so dominant in one of the world's earliest monumental architectural traditions requires understanding how early builders observed and interpreted their environment. The flat horizon of the desert, the movement of the sun, the bright clarity of the night sky, and the visible arc of the stars would have shaped their thinking. When the sky appears endlessly broad and the land appears vast, a towering structure stands out in a way that feels meaningful. Raising a massive stone into this open landscape creates a focal point, a landmark, a marker of presence and intention. Yet there is another aspect to this shape that complicates things. The pyramid not only resists time, it also conceals it. Its steep sides and stacked layers hide the process of construction. Once finished, the structure offers no obvious hints about how it was built. It becomes a static form that gives nothing away. Even when you study the interior passages or examine the casing stones, the overall impression remains one of mystery. The shape itself denies easy interpretation. For people living thousands of years later, that obscurity creates questions. How did a culture acquire the architectural confidence to construct something so massive? Where did the techniques come from? If this was the first structure of its scale, why does it look so complete, so refined, so lacking in the signs of experimentation? And if it wasn't the first, what earlier examples did not survive? These questions aren't attempts to insert drama into the story. They arise naturally from the structure's persistence and precision. When you consider that the earlier surviving pyramids are fully formed rather than incremental, the shape becomes more than a practical choice, it becomes a clue. Another way to understand the spread of this shape is to look at how humans respond to the challenge of building large monuments without advanced tools. When a culture experiments with stacking heavy materials, certain shapes fail quickly. Vertical walls collapse. Tall columns crack. Rounded forms require more complex construction techniques, but a broad base supporting a narrower top resists collapse even when the materials are uneven. This gives the pyramid shape a natural advantage. It survives where other shapes fall, and because it survives, it is more likely to leave a mark on history. However, the pyramids in Egypt complicate this explanation, because they represent a level of refinement far beyond the minimal requirements for stability. Their angles are consistent, their bases are precisely squared, their sides once had smooth outer surfaces that reflected light. The interior chambers show knowledge of stress distribution and ventilation. These features do not suggest a culture testing a shape for the first time, they suggest builders who understood the shape deeply. This raises another question. If the knowledge required for such precision existed, did it begin suddenly or come from a long, slow development? If earlier examples existed but were made from less durable materials, they would have vanished. Wood rots, earth erodes, mud brick collapses. Even early stone attempts could crumble beyond recognition if they were smaller or exposed to harsher environments. This is one reason the earliest pyramids we have today may not represent the earliest time the form was used. They may represent the earliest time it was used on a scale and with material strong enough to last. There are parallels in other cultures. South American pyramids, for instance, often have multiple construction phases stacked on top of one another. What looks like a single structure may actually be the result of generations of rebuilding, expanding and refining. Some early forms were modest and hidden within later layers. If Egypt followed a similar pattern but earlier phases did not survive, the earliest visible pyramids could appear more advanced than their origins actually were. The absence of earlier stone structures doesn't necessarily mean the form was invented suddenly. It may simply mean the earlier phases were too vulnerable to endure. Another aspect to consider is how the shape interacts with natural forces. The pyramid resists earthquakes better than many other forms. It also resists wind, shifting sand, and variations in temperature. This helps explain why pyramids survive in environments that destroy other types of architecture. A structure's survival creates the illusion that it was the dominant form of its time even if it wasn't. Other structures that once surrounded it may have vanished entirely, leaving only the strongest to represent the era. When archaeologists interpret the past based on what remains, they must remember that what survives is not a complete record. It is the result of nature filtering the past through the forces of erosion and stability. In this sense, pyramids may not only defy time, they may distort our perception of it. Their longevity makes them appear as if they stood alone in their era rather than as part of a broader cultural landscape. If a city once surrounded them, that city is now gone. If smaller stone structures once supported their construction, those stones may have been repurposed or destroyed. If earlier monuments influenced their design, those monuments may no longer exist. The shape that survives best becomes the shape we associate with the time, even if other shapes were equally common. This leads to another important idea. When cultures design monumental structures, they often draw inspiration from forms that already hold meaning. The pyramid may have represented a mountain, a mound of creation, or a connection between the earth and the sky. But these meanings do not have to originate in the same era as the structures. They could have roots in far older traditions that survive through memory rather than architecture. If certain symbolic interpretations of this shape persisted across generations, the knowledge might have reached later builders even after earlier examples vanished. The shape's relationship to sunlight may also be significant. When the sun rises or sets behind a pyramid, the shadow expands across the ground in a way that would have been hard to ignore in ancient times. The structure interacts with the movement of the sun, marking time, creating predictable patterns, and emphasizing cycles that would have mattered to early communities. Many cultures used natural features like mountains, hills, or cliffs for symbolic purposes. A built structure that mimicked these features could extend that symbolism. It could create a more controlled and intentional version of something the environment already provided. If the pyramid form emerged from this interplay between symbolism and practicality, it becomes easy to understand why cultures separated by vast distances arrived at similar shapes. When faced with similar needs and similar materials, people often develop similar solutions. But what remains uncertain is how far back these traditions might go. If a symbolic understanding of mountains or raised platforms existed long before the earliest surviving pyramids, then the architectural form might reflect memories of earlier practices that left no durable trace. A different approach to understanding the shape involves examining how early communities manipulated earth and stone in other contexts. Burial mounds, for example, appear in many parts of the world long before the rise of large stone pyramids. These mounds share the same general principle, a broad base supporting a raised top. They are simpler, smaller, and easier to build, but they represent an early version of the same instinct. If these traditions developed independently in different regions, the pyramid form may be a natural extension of earlier practices. If they were connected through migration or shared memory, the form may reflect older cultural links. In the case of Egypt, early burial structures known as mastabas show a clear transition from simple rectangular forms to more complex shapes. Some mastabas were combined into stepped structures. Later, the stepped form evolved into the smooth-sided pyramid. This progression is well documented, but it raises a question. If these transitions reflect a gradual development, why does the refinement of the final form appear so sudden? Where are the imperfect examples, the collapsed attempts, or the early experiments that didn't work? Some early pyramids did collapse or crack, but the leap from modest designs to the precision of the Great Pyramid still feels abrupt. That sense of abruptness is not evidence of anything hidden or dramatic. It simply suggests that the surviving structures represent only a portion of the architectural history. If the earlier stages of development occurred with materials or in regions that did not preserve well, those stages would be lost. What remains are the examples built from the strongest stone, supported by the most stable ground, and located in environments that favoured survival. This idea is reinforced by the presence of quarries near many pyramid sites. These quarries show signs of long-term use, with layers removed over different periods. Some layers appear more weathered than others, suggesting earlier activity. The quarry marks sometimes indicate methods that evolved over time. These gradual changes align with a long tradition of stoneworking that predates the most famous structures. If that tradition once included stone monuments or early prototypes of pyramid forms, their disappearance wouldn't be surprising. Smaller structures erode more quickly. Larger structures built with precise engineering survive. All of these observations point to the same idea. The pyramid shape doesn't just defy time because of the way it stands. It defies time because it confuses our sense of historical progression. It stands unchanged while everything around it vanishes. As centuries pass, the structure remains, but the context fades. Roads, houses, workshops, temples, and smaller monuments crumble away, leaving only the most resilient form. The past becomes represented by one shape while the rest is lost. When archaeologists attempt to rebuild the story, they are working backward from what remains rather than forward from what existed. This makes the pyramid both an anchor and a challenge. It anchors our timeline because it provides a physical structure we can measure and study, but it also challenges the timeline because it stands alone, without the full context of its origins. When you study the shape, it becomes difficult not to wonder whether the pyramid represents the culmination of a tradition rather than its beginning. If so, that tradition must have roots deeper than the surviving structures indicate. The shape takes on a new dimension. It becomes a reference point for understanding human ingenuity, resilience, and adaptation. It shows how people working with limited tools could build something that endures longer than almost anything made since. It also highlights the gaps in our knowledge and the ways time shapes what we can know. The pyramid form reflects not only the physical environment, but the long evolution of human thought, skill, and cultural memory. Technology is usually imagined as something that rises in a straight line from simple to complex. When we think of engineering, we often picture modern machines, advanced mathematics, and long chains of documented innovation. But long before writing took hold, long before the earliest known civilizations carved their names into stone, human beings were already solving complex problems using nothing more than observation, persistence, and ingenuity. The further back you look, the more you realize that engineering is not a modern invention. It is a human instinct that stretches deep into prehistory, practiced by people whose names are lost, but whose skills still echo in the structures they left behind. Looking at the feats accomplished by these early builders reveals a surprising truth. They didn't need metal cranes or modern mathematics to shape the world around them. They simply needed time, stable communities, shared knowledge, and the ability to learn from experience. When you consider the challenges early people faced daily, tracking animals across large distances, building shelters that could withstand harsh climates, crafting tools from stone, controlling fire, navigating by stars, the leap from these skills to engineering larger structures becomes easier to understand. These were people who paid close attention to their environment. They learned through trial and error. Over generations, their techniques improved, becoming traditions that shaped how later societies built their monuments. When thinking about prehistoric engineering, it's helpful to imagine a world without the distractions of modern life. People spent much of their time outdoors. They observed the behaviour of wind, the angle of sunlight, the patterns of shadows across the land. They learned how different types of stone fractured, how wood behaved under strain, how water carved channels through soil. Over centuries, these observations accumulated into practical knowledge. A technique that worked well was passed down. A method that failed was abandoned. Slowly, across many lifetimes, these small lessons formed the foundation of engineering practices that could be applied to large projects long before anyone wrote them down. For many early communities, the first large-scale engineering challenges involved managing water. Irrigation canals, embankments, and simple dams appear in the archaeological record thousands of years before the first known monumental stone structures. Building a canal requires planning, surveying, and an understanding of gradients. Constructing an embankment requires organised labour and knowledge of soil behaviour. These techniques may seem simple compared to later achievements, but they represent the same core principles found in large stone construction: measure, adjust, stabilise and repeat until the result holds. If a community can direct the flow of a river using earth and stone, it is not a huge step to imagine that they could also arrange stones to create a platform, a wall, or a burial mound. These early experiments in shaping the landscape built confidence and skill. Over time, as populations grew and societies stabilised, groups gained the manpower needed to attempt far larger projects. The success of one generation encouraged the ambitions of the next. Each attempt created knowledge that fed into the projects that followed. One reason prehistoric engineering feels mysterious to us today is because we tend to underestimate the scale of labour early people were willing to dedicate to a single purpose. Without machines, every task required human effort, but that effort wasn't scattered. It was focused. Entire communities worked together because their lives depended on cooperation. This allowed early societies to mobilise hundreds or even thousands of individuals for long-term projects. When you imagine such effort concentrated on a single structure for many years, the idea of moving enormous stones becomes easier to grasp. Another factor often overlooked is the use of simple machines. Levers, rollers, sledges and ramps appear modest compared to modern cranes, but when used skillfully, they amplify human strength dramatically. A wooden lever can multiply force several times over. A well-designed sledge reduces friction. Ramps made from earth or rubble distribute weight safely. None of these tools require advanced metallurgy or complex mathematics. They only require practical experience and the willingness to test different approaches. Early builders around the world discovered these principles independently, guided by observation and necessity. One of the clearest examples of prehistoric engineering skill comes from megalithic sites that predate many known civilizations. At places like Stonehenge, researchers have found evidence that massive stones were transported over long distances using combinations of sledges, rollers, and human coordination. Experiments conducted in modern times demonstrate that teams of people can move multi-ton stones at surprising speeds with only simple equipment. While the exact methods used at ancient sites remain debated, the basic idea holds. Given enough time and enough people, early engineers could achieve feats that look impossible from a distance. The use of stone in these early structures provides another clue about prehistoric engineering. Stoneworking begins with understanding how different stones behave under pressure. Flint shatters sharply, Limestone cuts more easily. Granite requires more force but resists erosion. Over time, people learned how to shape stone using pounding tools, abrasives, and controlled impact. These techniques appear in the archaeological record in the form of polished axes, carved vessels, and finely shaped blades. The same methods applied to smaller tools could eventually be scaled up to larger building projects, forming a continuous line of development from hand-sized tools to monumental architecture. Ancient quarries show evidence of sophisticated extraction methods. Grooves cut into rock faces reveal how early workers removed blocks in predictable shapes. Some quarries contain channels that allowed water to penetrate natural fractures, loosening blocks for easier removal. Others show signs of heating and cooling cycles used to crack stone. While these techniques may seem basic, they represent significant understanding of material properties. They show that early engineers weren't simply striking stone at random. They were applying tested methods that required planning and coordination. Another aspect often associated with prehistoric engineering is the alignment of structures with celestial events. Many ancient monuments, including some older than the pyramids, align with solstices, equinoxes, or specific star risings. Achieving this accuracy requires careful observation over long periods. This doesn't mean early people needed advanced mathematics. They only needed to watch the horizon, mark positions, and track the movement of the sun or stars from year to year. With a long enough baseline of observation, even simple markers can guide the orientation of large structures. This ability to observe and record natural cycles connects directly to engineering. A group capable of marking solstice points can also measure shadow lengths. A group capable of tracking star positions can create straight lines over long distances. These are the same skills needed to level foundations, square corners, and align walls. Early builders didn't need metal tools or written mathematics to create accurate geometry. They needed only consistent observation, steady hands, and techniques passed down through generations. Many prehistoric societies also demonstrated advanced understanding of resource logistics. Moving thousands of stones, feeding large workforces, and organising seasonal labour all require planning. Archaeologists have found evidence of storage pits, animal pens, temporary worker camps, and distribution systems associated with ancient building projects. These discoveries show that early people managed resources carefully. Large constructions were not random events. They were organised undertakings supported by infrastructure and forethought. In some regions, archaeologists have identified ancient roadways that appear to have been used specifically for transporting heavy stones. These paths often show signs of repeated usage, with compacted surfaces and traces of tool marks. In other areas, wooden tracks have been found preserved in peat bogs, suggesting that early engineers experimented with ways to reduce friction and control movement. This kind of infrastructure adds to the understanding that monumental construction was a planned communal effort, rather than a spontaneous or improvised task. Another consideration is the role of seasonal cycles in engineering. Many early societies worked on large projects during certain parts of the year when labour was available. During harvest seasons, people were needed in the fields. During other times, when agricultural work slowed, labourers could contribute to construction. This cyclical approach allowed massive projects to continue without overwhelming the community. Over decades, even modest annual contributions of labour could create enormous structures. Beyond the physical skills required, prehistoric engineering also relied on a cultural component. Traditions, rituals, and shared beliefs often motivated large groups to work toward a common goal. Building a monument was not always a practical task. It might have held spiritual, social, or symbolic importance. These motivations strengthened community bonds and justified the enormous effort required. When people believe they are contributing to something meaningful, they are willing to invest time and energy beyond what would be expected for everyday survival. In many ancient cultures, engineering knowledge was preserved through apprenticeship. Skilled builders taught younger generations. Techniques were practiced repeatedly. Mistakes were corrected. Over time, this created a lineage of expertise that could stretch across many lifetimes. Even without written instructions, this continuity allowed complex knowledge to survive. If a community had maintained building traditions for centuries, the achievements we see today become more understandable. The knowledge wouldn't have to emerge suddenly. It would grow gradually through practice. One important thing to recognise is that prehistoric engineering doesn't require imagining anything beyond human capacity. It requires patience, cooperation, and long-term stability. Human groups living in favourable environments with consistent food sources could dedicate significant time to building. If those groups maintained traditions over many generations, their skills could develop to levels that would seem extraordinary when later viewed in isolation. The absence of earlier surviving structures doesn't negate the existence of that knowledge. It only means those structures didn't endure. Some of the most intriguing hints of prehistoric engineering come from places where natural features appear to have been modified by human hands long before the rise of known civilizations. In certain regions, terraces, shaped hillsides, or altered rock formations suggest early attempts at controlling landscapes. These modifications may not have been intended as monuments. They might have served practical purposes like farming, water control, or settlement organization, but the skills developed through such work could have contributed to later achievements. Looking at the pyramids through this lens doesn't diminish their significance, it enriches it. It suggests that the builders drew from a deep reservoir of inherited knowledge. They may have refined techniques learned from earlier societies, adapted them to new materials, and applied them to unprecedented scales. Rather than appearing suddenly, the skills involved in pyramid construction may represent the culmination of practices that began long before the established timeline. The idea of impossible feats often arises when the gap between surviving evidence and actual ancient capabilities becomes difficult to reconcile. When only the largest structures endure, it can seem as though they emerge from nowhere. But when you consider the thousands of years during which earlier knowledge could have developed and disappeared, the idea becomes less surprising. Human beings have always pushed the boundaries of what they can build, using whatever tools they had available. There is also the matter of experimentation. Early builders would have learned through repeated attempts. Some structures may have failed, others may have succeeded but left no trace. Over time, the accumulated experience would guide larger and more ambitious projects. The success of one generation becomes the foundation for the next. This gradual progression doesn't leave a clear archaeological footprint, but it explains how monumental engineering could arise without the need for advanced technology or lost civilizations. As engineering knowledge grew, so did the confidence to attempt larger structures. A community that successfully built a large earthen mound might later attempt a stone version. A community that mastered transporting small stones might eventually try moving larger ones. A culture that built ceremonial structures might be inspired to create something taller or more durable. The pyramid form, with its forgiving stability, would naturally be the shape chosen when the ambition to build upward became strong enough. The idea of prehistoric engineers accomplishing feats that seem extraordinary today doesn't require imagining abilities beyond what humans possessed. It requires recognizing that human ingenuity has always been present, even in periods poorly represented by surviving artifacts. People have always experimented with their environment. They have always sought ways to improve the structures around them. They have always pushed against the limits of their tools and materials. If early societies in North Africa or neighbouring regions developed substantial engineering traditions during periods when the climate was wetter and the land more fertile, the physical evidence of those traditions could have vanished as the environment changed. As the land dried and population shifted, the stone structures we see today might represent the tail end of a much longer continuum. This is not a conclusion. It is simply a possibility grounded in the understanding of how knowledge evolves and disappears. Following this possibility doesn't require discarding the established historical record. It simply involves acknowledging the gaps within it. It invites us to consider that prehistoric engineers may have been more advanced than the surviving evidence suggests. Their accomplishments may have laid the groundwork for later achievements, even if the physical traces of their earliest efforts are gone. It's easy to imagine that all major civilizations would leave behind unmistakable traces: cities, monuments, artifacts, inscriptions, things too solid to vanish completely. But when researchers step deeper into the early human timeline, they find an unexpected reality. Most of the cultures that ever existed left almost nothing for us to find. Not because they were insignificant or primitive, but because the environments they lived in, the materials they used, and the forces of time worked against preservation. When you start looking at the ancient world through this lens, the possibility that entire civilizations rose and faded without leaving a clear archaeological footprint becomes less speculative and more a matter of probability. One of the first things archaeologists learn is how fragile the record of human history is. Even in the short span of the written history, countless cities have disappeared beneath rivers, volcanic ash, shifting coastlines, or layers of accumulated soil. Over thousands of years, many of these sites become so deeply buried that they only resurface by accident. If a single city from a relatively recent era can vanish this easily, then societies from far earlier periods, ones without stone architecture or writing, would be even more vulnerable to complete erasure. A good place to begin thinking about these missing civilizations is with climate. The Earth has gone through major environmental changes during the last 20,000 years, and each shift affected where people lived and how their settlements fared. When the Sahara was covered in grasslands and lakes, it could have supported large populations. When it dried out, those communities would have moved or collapsed, and anything they built from organic materials would have disintegrated. In a region where sand can swallow structures within a few decades, it doesn't take long for an entire way of life to vanish from the surface. The same is true of coastal regions. At the end of the last ice age, sea levels were significantly lower than they are today. Many ancient coastlines, where early communities would naturally have settled, are now underwater. If any civilizations developed along these ancient shores, their settlements would lie far below the modern ocean surface, out of reach of most archaeological efforts. Some underwater finds around the world hint at the existence of older settlements, possibly more complex than expected for their time. But these sites are difficult to study, and many others are likely still undiscovered beneath the world's oceans. Then there are river valleys that shifted course. When a river moves, it sometimes buries entire communities beneath silt. These layers accumulate rapidly. After just a few centuries, the original settlement may be dozens of feet underground. When the river finally erodes elsewhere, the buried site remains hidden. Large areas of the world contain multiple such layers, representing different periods of human history stacked on top of one another. Some of these layers have never been excavated. When archaeologists dig only a few meters deep, they miss earlier chapters preserved much farther below. These environmental shifts make it clear that absence of evidence does not necessarily mean absence of civilization. It simply means that whatever evidence once existed either decayed or was buried too deeply to recover. Another factor that contributes to the disappearance of ancient cultures is the materials they used. Humanity did not begin with stone architecture. For most of prehistory, people built their homes and communal structures from wood, reeds, earth, or mud. These materials deteriorate quickly. Even in ideal conditions, structures made from wood last only a few centuries. In humid climates, they can vanish within decades. If an early culture built sophisticated buildings from these materials, almost none of them would survive. In parts of Anatolia, the Near East, and Southeast Asia, archaeologists have discovered traces of ancient wooden structures preserved only because they were burned, waterlogged, or buried under unusual conditions. These rare finds reveal levels of complexity that weren't expected for their age. They show that people were capable of building large communal structures and organising themselves in ways previously associated only with later civilizations. These discoveries raise an important point. If such complexity appears in isolated finds, what might lie in regions that haven't been investigated, or in places where preservation conditions were poor? The timeline of human technological development complicates the picture further. In various parts of the world, people were creating symbolic art, seafaring over long distances, and experimenting with astronomy far earlier than once assumed. These achievements suggest societies with stable populations, rich traditions, and organised social structures. But if those societies didn't use durable materials, very little of their material culture would survive. Researchers sometimes find sophisticated objects out of context, tools finely shaped, carvings unusually precise, or patterned artifacts that hint at complexity. These objects come from societies that, by all indications, had the capacity for organised craftwork and possibly for more extensive cultural development. But because they left so few traces, the larger picture remains largely invisible. Another reason entire civilizations might be missing is that archaeological research is unevenly distributed. Some regions have been extensively explored, others remain largely untouched due to political instability, remote geography, dense vegetation, or limited resources. Even in well-studied countries, large areas contain no archaeological surveys at all. The world's deserts, mountain ranges and jungles hold countless secrets simply because no one has looked. It's not unusual for a major ancient site to be discovered unexpectedly during road construction, mining, or agricultural expansion. These accidental finds remind us that much of the world's history lies hidden beneath ordinary landscapes. In some regions, the terrain makes discovery particularly difficult. Dense forest can conceal ancient structures even when they are made of stone. Using modern technologies like airborne scanning, researchers have recently discovered vast networks of buildings, roads and terraces beneath jungle canopies, sites previously unknown and undetected by ground surveys. These findings show that entire civilizations can remain hidden even in modern times. If this can occur with structures only a few thousand years old, then much older sites made from less durable materials could easily remain undiscovered. Migration patterns also play a role in the disappearance of early civilizations. When a climate becomes inhospitable or resources run out, communities move. As they relocate, they may abandon settlements that later erode or become buried. Over many generations, the memory of these earlier homes may fade. Without writing, knowledge of these past locations would survive only through oral traditions, which themselves change over time. When stories change, they lose the specificity that might guide archaeologists to earlier sites. Without physical evidence, those societies effectively vanish from the historical record. In some cases, early groups developed advanced skills without ever transitioning to the kinds of societies that leave extensive archaeological remains. These could include fishing communities with deep knowledge of navigation, mountain groups with expertise in stoneworking, or nomadic cultures with impressive craftsmanship. These groups may have reached levels of sophistication comparable to early settled civilizations, but because they didn't build large cities or leave behind monumental architecture, they appear as small points in the archaeological record rather than full cultural narratives. It's also possible that some civilizations rose and fell within regions where conditions were never suitable for long-term preservation. Heavy rainfall, acidic soil, or rapid vegetation growth can erase artifacts quickly. If a culture flourished for a few hundred years and then declined, the speed of environmental change could easily remove almost all physical evidence. In such cases, even pottery might not survive. Only stone tools or fragments of bone might remain, scattered in ways that reveal little about the culture as a whole. The idea of missing civilization sometimes raises concerns about speculation, but many archaeologists acknowledge that the gaps in the record are enormous. There are entire periods where human activity is poorly understood, not because nothing happened, but because the evidence hasn't survived. When you look at how long humans have existed compared to how much of our material history remains, the imbalance becomes stark. More than 90% of human existence took place before writing, and most of that time is represented by scattered artifacts, rather than coherent cultural timelines. This doesn't mean there were vast advanced civilizations equal to or surpassing later ones. It simply means that cultural complexity takes many forms, and not all of them leave clear traces. A society might be advanced in navigation, astronomy, or engineering without creating large stone structures. A culture might excel in agriculture or social organization without developing writing. These nuances challenge the idea that what we see today represents the full range of ancient human achievement. Occasionally, archaeologists uncover evidence that hints at cultural development far earlier than previously thought. These discoveries don't necessarily rewrite history dramatically, but they widen the timeline. A settlement older than expected. A tool more sophisticated than its context suggests. A burial practice that implies social stratification. These findings act like small windows into worlds that were once vibrant, but now barely visible. Each discovery reveals how much we've overlooked simply because the evidence didn't survive long enough. In some cases, oral traditions preserved by indigenous groups contain memories of earlier ways of life that archaeological records don't capture. These stories may describe changes in climate, long migrations, or periods of prosperity followed by hardship. While oral traditions aren't precise historical documents, they offer hints about episodes that left little physical trace. They remind us that memory persists even when artifacts disappear. When combined with geological evidence of environmental changes, these stories sometimes align with broader patterns that deepen our understanding of the ancient world. Considering all of this, the question isn't whether early civilizations existed and vanished. The question is how many, how complex and how influential they might have been. Some may have been small but stable, passing down traditions that later influenced more visible cultures. Others may have grown larger but left behind fragile remains that couldn't survive environmental shifts. Still others may have flourished for long periods before being displaced or absorbed by later groups. When you apply this perspective to the pyramids, the possibility of older cultural inputs becomes easier to imagine. The skills required for precise stonework, advanced surveying, and large-scale labour organisation could have deep roots in earlier societies whose traces are now subtle or lost. The pyramid form might reflect not only the ingenuity of the builders we know, but also the accumulated knowledge of cultures we don't. The absence of clear predecessors in the archaeological record may not reflect a sudden leap. It may reflect the loss of earlier examples. Thinking about these missing civilizations doesn't diminish the accomplishments of known ancient cultures. Instead, it enriches them. It places their achievements within a larger, more dynamic human story. It suggests that the builders of early monuments were heirs to long traditions, stretching across forgotten landscapes and vanished communities. It shows how human knowledge can outlive the societies that created it, carried forward through memory, migration, and shared experience. Across many parts of the world, long before writing appeared, people shared stories to explain their origins, describe the forces around them, or preserve events that shaped their communities. These stories travelled from person to person, from one generation to the next, and gradually settled into what we now call myths. Today, myths are often viewed as symbolic, imaginative, or even fantastical. But when researchers examine ancient oral traditions closely, they sometimes find hints of real events preserved within them. Not detailed reports or precise accounts, but fragments carried forward through memory, condensed over time into narrative form. When exploring the possibility that older civilizations may have existed before the ones we recognize today, these myths become another source to consider, not as literal descriptions, but as echoes of experiences that might stretch back far earlier than the surviving physical evidence. One of the reasons myths matter in discussions of deep history is that human memory behaves differently when preserved through oral tradition than through writing. Written texts freeze a story at a moment in time. Oral stories change slowly as each teller adapts the narrative for a new audience. The structure remains, the core themes persist, but the details shift. Over hundreds or thousands of years, these stories can drift significantly from their origins while still carrying recognisable patterns. When multiple cultures tell different versions of similar stories about floods, migrations, lost lands, great builders, or sky events, researchers sometimes wonder whether these shared patterns reflect psychological tendencies, environmental observations, or memories of experiences long forgotten by the societies that inherited them. A striking example comes from flood stories. Flood myths appear on nearly every continent, each with unique cultural characteristics, but all focusing on overwhelming water reshaping the world. For many years, these stories were dismissed as symbolic or moral tales. Later, when geological research revealed that sea levels rose rapidly at the end of the last ice age, the idea that these myths could preserve fragments of real events gained traction. Coastal communities living near ancient shorelines would have witnessed dramatic flooding as glaciers melted. Their memories, told and retold over generations, could have evolved into the stories we now associate with mythology. These stories don't need to describe exact events to reflect real environmental changes. They represent how early people processed transformations in their world. This connection between myth and memory becomes even more compelling when examining traditions that reference ancient builders or structures that no longer exist. In some regions, mythic stories speak of people who shaped stone in ways that seem beyond ordinary capabilities, not in a fantastical sense, but in terms that suggest older cultural practices. These stories may be exaggerated over time, but exaggeration itself often begins with a kernel of truth. If early societies built structures that later collapsed, eroded, or disappeared, the physical evidence might be gone while the memory persists through narrative. Those memories could then evolve into tales of great ancestors, legendary architects, or lost cities. There's also the question of how myths preserve information about geography. Some stories describe landscapes that appear unfamiliar today, rivers flowing where none exist, forests in places that are now deserts, coastlines far from their current boundaries. When researchers compare these mythic geographies to reconstructions of ancient environments, there are occasional overlaps that are difficult to dismiss entirely. Again, these stories aren't precise maps, but they may reflect memories of older landscapes passed down long after the environment changed. In cultures across Africa, Asia, and the Americas, myths often include references to earlier ages marked by distinct environmental conditions. Sometimes these stories describe times of abundance, followed by periods of hardship, drought, or cold. These shifts echo what paleoclimate studies reveal about ancient climate cycles. It's possible that early societies experienced these changes directly, and that their descendants encoded those experiences into narratives to explain why their world changed. When people lack scientific frameworks, memory often becomes descriptive storytelling. Over time, the stories remain even if the original context fades. A compelling idea among some anthropologists is that myths might preserve memories of interactions between different cultures. When a later society encounters the remains of an earlier one, they may interpret those remains through the lens of story rather than analysis. If people in a later era discovered large stones, abandoned structures, or unusual artifacts, they might attribute them to legendary beings or ancient ancestors with extraordinary skills. These interpretations could then become embedded in myth. In this way, a myth might indirectly reflect the existence of older cultural traditions that left behind minimal physical evidence. Some of the most interesting mythic patterns relate to knowledge of the sky. Ancient stories in multiple cultures describe observations of stars, movements of celestial bodies, or unusual events like comets or supernovae. These descriptions often appear embedded within symbolic narratives, but when astronomers examine them closely, they sometimes find correlations with actual events. A bright star recorded in a myth may correspond to a known supernova. A tale of shifting seasons may reflect past changes in climate. These connections show how oral traditions can preserve observations made by people who lived long before historical records. Considering myths as possible containers of memory doesn't mean accepting every story as historical. Many myths evolved from symbolic, ritualistic, or moral roots. But it does mean recognizing that oral narratives often blend real experiences with imagination. When a culture experiences an unusual event, such as a dramatic geological shift, a major flood, a volcanic eruption, or the collapse of an earlier settlement, the memory of that event might survive long enough to enter the mythic record. This idea becomes particularly relevant when thinking about civilizations we might have missed. If early societies developed in regions that later became inhospitable, their material evidence might be gone, but the stories of their existence could have survived in altered form. For example, a myth about a lost land might reflect an actual region submerged by rising seas. A myth about a vanished people with great skills might reference a group displaced by environmental change. A myth about ancient builders who shaped stone or lifted enormous weights might preserve a memory of construction techniques no longer practiced. In several cultures, myths describe cycles of creation and destruction, with earlier ages wiped out by natural forces. These cycles sometimes align with known geological events, such as volcanic eruptions or abrupt climate shifts. While the mythic framing may be symbolic, the underlying structure could reflect memories of real disruptions that scattered populations and erased evidence of their lives. If those earlier groups built structures or developed traditions that influenced later societies, the only surviving trace might be the stories carried forward by their descendants. Another intriguing aspect of myths is the presence of knowledge that seems out of place for the time when the stories were written down. Some myths contain detailed astronomical knowledge not recorded elsewhere in archaeological evidence. Other myths describe navigation techniques used long before the earliest known seafaring tools. These apparent anomalies don't necessarily indicate advanced civilizations. They could simply show that knowledge existed earlier than expected, but left little material trace. As people moved, migrated, or adapted to new environments, they carried their knowledge with them even if the physical evidence did not survive. The role of myth in preserving information becomes clearer when comparing the stories of groups that were separated by large distances. When two cultures on opposite sides of the world describe similar events, not identical stories, but stories with matching structural elements, it raises questions about what might have inspired them. Shared psychological patterns can explain many similarities, but in other cases the similarity might reflect common experiences, such as climate shifts or encounters with earlier remnants of human activity. Myths often compress long periods into short symbolic narratives, so the events they describe may represent processes that unfolded over centuries rather than single moments. Language itself preserves clues about older cultural memories. In some regions, words describing ancient events or lost landscapes survive long after the events themselves are forgotten. These linguistic remnants can persist even when there is no physical evidence. When combined with myths, they sometimes suggest deep cultural roots extending beyond the timeline indicated by surviving artifacts. For example, certain myths that describe earlier peoples or forgotten technologies may align with shifts in language patterns, hinting at migrations or cultural blending not fully represented in the archaeological record. What makes myths particularly valuable for exploring deep history is the way they preserve emotional truths even when factual details erode. A story about a great flood may not describe the exact height of the water or the precise location of a submerged settlement, but it preserves the emotional impact, a sense of loss, migration, or transformation. These emotional imprints can last far longer than physical structures. Archaeological evidence can vanish, but stories told around fires, passed from elders to children, can survive for tens of thousands of years in evolving forms. When combined with scientific evidence, these stories sometimes align in ways that reveal hidden layers of the past. Researchers studying the histories of indigenous groups have found remarkable examples of oral narratives that preserved memories of real events for thousands of years. Some Aboriginal Australian stories reference coastline changes that occurred more than 7,000 years ago. Certain Pacific Island myths describe volcanic eruptions that geological evidence confirms. In North America, some oral traditions mention impacts or environmental changes that match known prehistoric events. These examples demonstrate that oral memory can extend far deeper into the past than many once believed. If myths can preserve memories across millennia in these contexts, it's plausible that ancient Egyptian myths or Near Eastern stories could contain fragments of even older cultural memories. Perhaps tales of earlier ages reflect encounters with older groups whose material traces have not survived. Perhaps stories of great ancestors who raised the land or built the first structures reflect distant memories of builders who predated known civilizations. Perhaps myths describing cycles of creation and destruction echo the rise and fall of cultures erased by time. Of course, it's important to approach these possibilities carefully. Not every myth contains hidden history. Many stories developed independently of actual events. But when exploring long-lost periods where evidence is scarce, oral tradition provides another layer of insight. It invites questions. It encourages researchers to consider whether mythic patterns align with environmental data, migration models, genetic evidence, or the faint archaeological traces of earlier societies. When you place this perspective alongside the possibility that entire civilizations left little physical trace, the idea that myths might preserve fragments of their memory becomes more compelling. Even if only hints remain, stories of earlier peoples, lost knowledge, or vanished lands, they help fill the gaps created by time. They offer a bridge between what we know and what we can only infer. They remind us that human memory does not begin with writing. It begins with storytelling. Viewed this way, myths become much more than symbolic tales. They become another part of the archaeological toolkit, offering glimpses into experiences that shaped humanity long before the earliest surviving structures were built. They help connect the visible history of the pyramids to the invisible layers that may lie beneath it, both literally and culturally. When you look at the long arc of human existence, something becomes immediately apparent. The stretch of time during which people lived as hunters, gatherers, small community builders, and seasonal migrants dwarfs the span of recorded civilization by an overwhelming margin. The timeline doesn't resemble a steady climb from simple tools to cities. Instead, it looks like a vast plateau followed by a sudden and dramatic rise. For tens of thousands of years, humans lived in a way that changed little from generation to generation. Then, in a relatively brief period, cities appeared, writing emerged, agriculture spread, and monumental structures rose from the earth. This long pause, this enormous span where humanity remained nearly static by material standards, presents one of the most puzzling aspects of our deep past. Understanding this pause requires recognizing how much of early human life was shaped by environment, survival pressure, and the rhythms of nature. Early humans were not lacking intelligence or creativity. Their brains were essentially the same as ours. They were capable of complex language, social organization, symbolic thinking, and intricate tool-making long before the first city existed. Yet for most of human history, these abilities did not translate into the kind of rapid technological growth we associate with civilization. Instead, progress moved slowly, almost imperceptibly. One explanation lies in the nature of early human communities. Small groups, often spread thinly across large landscapes, had limited population density. Innovation thrives in dense environments where ideas spread rapidly. But early people lived in groups that rarely exceeded a few dozen individuals. Many of these groups interacted with others only occasionally. In such conditions, new ideas emerged, but they spread slowly. A useful tool developed in one region might take centuries to reach another. Cultural change can only accelerate when enough people share knowledge consistently. Before large settlements existed, this kind of exchange was rare. Another factor involves the climate. Over the last several 100,000 years, the Earth experienced repeated cycles of glaciation and warming. These dramatic environmental shifts shaped where people could live, how they obtained food, and what resources were available. During colder periods, survival demanded mobility. Communities followed migrating animals and seasonal plant growth. In these conditions, building permanent structures or maintaining large settlements was impractical. As a result, early humans focused on adaptability rather than infrastructure. Their knowledge advanced in terms of survival skills, but not necessarily in terms of permanent technology. During warmer periods, the environment opened new opportunities. Regions that were once frozen became habitable. Forests expanded. Rivers flowed in areas previously too cold for settlement, but these warmer spans didn't always last long enough for long-term cultural or technological growth. Stability is one of the key ingredients of civilization. Without stable seasons, reliable food sources, and predictable environments, people cannot develop farming, build cities, or accumulate wealth. The pauses between glacial cycles were often too short to sustain these developments. This raises an interesting point. If early humans were capable of the same level of thought as modern humans, then why didn't they create civilizations earlier? One possibility is that they did, but those early civilizations were small, dispersed, and reliant on materials that didn't preserve well. If a community built homes from wood near a river valley that flooded regularly, the structures would be washed away long before later societies discovered the area. If another community created complex social systems in a region that later became desert, their settlements might erode into dust. What looks like a pause in the archaeological record might simply be a gap in what survived. Another perspective on the long pause involves the role of agriculture. Farming changed everything. Once people learned to control their food supply, populations grew. Larger communities formed. People no longer had to follow seasonal migrations. They could stay in one place long enough to build permanent homes. This stability allowed knowledge to accumulate. Innovations no longer disappeared when groups moved. Skills could be passed from parent to child and from elder to apprentice, creating a continuous chain of learning. Farming also produced surplus food, freeing some members of the community to specialize in other tasks: toolmaking, construction, record-keeping, and leadership. These specialists became the backbone of what we now recognize as civilization. But agriculture did not develop evenly around the world. Some regions adopted it earlier than others. Some communities resisted it. Some climates made it difficult. This uneven adoption contributes to the appearance of a pause. Regions rich in wild grains or reliable rainfall transitioned more easily into farming. Others depended on fishing, hunting, or gathering practices that remained stable for thousands of years. In these places, the lifestyle was sufficient. Innovation was not necessary for survival. When change happened later, it often occurred through contact with farming communities rather than independent development. This unevenness also shaped how cultures grew. A region with plentiful natural resources could support large populations even without farming. Another region with harsher conditions might remain sparsely populated even after developing simple agriculture. These variations help explain why civilizations appeared at different times in different locations. They also highlight why the pause in technological progress lasted so long globally, even though certain areas eventually broke through earlier. When examining the long pause, another important element emerges: the disappearance of early experimentation. The archaeological record preserves only a fraction of human activity. If a group experimented with farming thousands of years before it became widespread, their early efforts might not have left clear evidence. Farming doesn't always begin with large fields. It starts with tending wild plants, protecting certain plots, or scattering seeds near settlements. These small-scale experiments leave almost no trace. Only when farming becomes central to a society's survival does the evidence become visible in the archaeological record. It is entirely possible that early attempts at farming occurred multiple times, failing or remaining small before eventually succeeding in more favourable conditions. The same logic applies to early attempts at construction. If a group built small structures from stone or created simple ceremonial sites, those structures might erode away or be buried over time. Only the largest and most durable monuments survive. This creates an impression that monumental building appeared suddenly. But the knowledge to create such structures likely evolved over long periods, through countless experiments that left no trace. There's also the question of population bottlenecks. Genetic evidence suggests that at several points in early human history, populations shrank dramatically due to environmental stresses. When populations drop, knowledge can be lost. Skills practiced by only a few individuals may disappear entirely if those individuals do not survive, or if their communities fragment. When populations grow again, they must relearn skills that were once known. These cycles of growth and loss contribute to the appearance of slow development. When we talk about the pause in civilization, it's important to recognize that the pause is visible only when looking through the lens of material culture. Innovation is not always visible in the objects people leave behind. A group may develop sophisticated storytelling, complex social norms, or ceremonial traditions that leave little physical evidence. These forms of cultural development contribute to the richness of human life, but do not necessarily lead to the material structures archaeologists can detect. In this sense, the pause in visible progress does not mean a pause in human creativity. It's also worth noting that technological progress does not always align with human priorities. Early communities focused on survival, social cohesion, and mobility. They invested time in activities that increased their resilience: hunting, gathering, crafting tools, and maintaining social bonds. Building large structures or accumulating wealth may not have been as important. As long as their environment provided what they needed, there was little motivation to pursue dramatic change. The idea of progress itself is a modern concept. Early humans likely valued stability more than innovation. When environmental stability finally arrived in certain regions, the conditions were right for civilization to emerge. The climate became predictable. Rivers flooded regularly. The growing season lengthened. Populations increased. These changes enabled the development of farming, which in turn supported larger communities. Knowledge accumulated, and construction techniques improved. What had been a long pause suddenly transformed into rapid growth. But the long pause also hides a subtle possibility. Early humans may have been far more active and experimental than the archaeological record suggests. They may have built settlements along coastlines now submerged. They may have developed social structures that did not rely on durable materials. They may have experimented with building forms that left no trace. If even a few of these early cultures reached a level of complexity greater than what we see in the surviving record, their influence might have carried forward into later civilizations. This raises an interesting question. If early societies carried knowledge through oral tradition, practiced skills that did not rely on durable materials, and migrated widely, could they have formed the foundation for later monumental builders? The answer is difficult to prove, but not unreasonable to consider. Human knowledge does not begin at the moment writing appears. It builds across generations, shaped by memory and experience. Early groups may have passed down insights about the land, the sky, or the behaviour of materials that later civilizations refined into more recognizable forms of engineering. Thinking about the long pause this way shifts the perspective on monumental structures like the pyramids. Instead of appearing suddenly in the historical record, they may represent the culmination of a much older tradition, carried quietly through generations that left a little trace. If earlier societies experimented with stoneworking, alignment, or surveying, even at modest scales, the skills needed to plan a pyramid would not have emerged suddenly. They would reflect deep cultural memory, refined and expanded by later builders. The long pause, then, is not a blank space. It is a landscape of hidden development, quiet experimentation, and slow accumulation of knowledge. It represents the vast majority of human experience, during which people learned how to observe, adapt, and shape their environment in ways that set the stage for everything that followed. Even though the physical evidence of these early eras is limited, their imprint may still exist in the achievements of later civilizations. Considering the possibility that the pyramids might be older than the historical framework usually assigned to them, invites a different way of looking at everything that surrounds their creation. It doesn't ask you to replace the established timeline outright. Instead, it encourages you to explore what would change if the structures were rooted in traditions that began long before the earliest written records. Thinking through those implications isn't about abandoning what archaeology has uncovered. It's about expanding the context, imagining how the pyramids might fit into a much deeper story of human development, one that stretches beyond the boundaries of recorded history and into eras where knowledge moved without leaving durable traces. One of the first implications touches on the origin of architectural knowledge. If the pyramids were built earlier than currently believed, or if the techniques behind them originated in a much older cultural tradition, then the skills needed to construct them might not represent a sudden burst of innovation. They might reflect practices refined over many generations, shaped quietly during periods when the environment supported stable populations and long-term learning. This would mean the architectural sophistication we see did not emerge abruptly. It would have been the product of accumulated experience that belongs to cultures we know only faintly or not at all. If that's the case, the pyramids become part of a larger chain of knowledge rather than isolated achievements. Their precision would then represent the visible portion of a much deeper foundation. It would imply that earlier societies experimented with surveying, stoneworking, and spatial organization in ways that left minimal physical evidence. The absence of clear predecessors in the archaeological record would not mean those predecessors never existed. It would mean they didn't survive the environmental and climatic changes that erased most early human structures. In this scenario, the monumental scale of the pyramids becomes less surprising. It becomes the natural continuation of practices carried over from older cultures. Another implication involves rethinking how we understand the flow of ancient knowledge. Today, it's common to imagine civilizational development as a series of isolated rising and falling cultures. But if the pyramids or their underlying traditions stretch back further, then the transfer of knowledge might have been more interconnected than it appears. Groups migrating across landscapes could have brought ideas from older regions into newer ones. Techniques could have travelled quietly over long distances through small cultural exchanges, trade, or seasonal interactions. Even if the earliest societies responsible for those ideas left no durable remains, their influence could still appear in later monuments. This kind of continuity would reshape how we see early humanity. Instead of imagining sudden leaps in technology, we might begin to see a long thread running through the deep past, a thread of shared understanding that survived environmental shifts, migrations, and cultural change. The pyramids could then represent a point along that thread, where accumulated knowledge was expressed at a scale large enough to survive. A related implication involves how we interpret ancient symbols and traditions. Many aspects of Egyptian culture draw from older practices: solar cycles, ceremonial alignments, spiritual concepts about death and renewal, and symbolic associations with natural elements. If the pyramids are connected to a deeper timeline, then these symbols may trace their origins to much older worldviews, shaped by societies living in environments very different from those of later dynastic Egypt. Elements of early mythology, cosmology, and ritual might reflect memories or interpretations of events that took place long before recorded history. If symbolic traditions endured across thousands of years, carried through oral memory, then the pyramid form itself could reflect cultural meanings inherited from earlier times. The choice to build upward might represent continuity with older traditions about the sky, the horizon, or creation. These meanings may have evolved over time, but their roots could stretch deeper than the surviving texts suggest. In this view, the pyramids become cultural anchors, preserving interpretations of the world that otherwise would have vanished. Another area affected by the idea of older pyramids involves population dynamics. If the structures were created during an earlier period of greater environmental richness, such as when the Sahara was green, then the populations supporting their construction might have been larger, more stable, and more interconnected than the traditional timeline implies. These populations could have organised large labour forces, maintained extensive trade networks, and supported specialised crafts. When the climate changed and regions became arid, these societies might have migrated, collapsed, or transformed, leaving behind only the stone monuments capable of enduring the new conditions. Understanding how climate shapes civilization is essential here. During wetter eras, North Africa may have supported not only nomadic groups but settlements with enough stability to sustain long-term construction projects. When those landscapes dried, the people dispersed. Their knowledge survived, but their settlements did not. This would create the illusion of sudden complexity in later structures when, in reality, the knowledge had deeper roots. The pyramids might then reflect the legacy of a climate cycle rather than a moment in time. Considering a deeper age for the pyramids also raises questions about the disappearance of earlier engineering traditions. If people had the capability to build large structures earlier than currently recognised, where are the earlier examples? The likely answer lies in the fragility of early materials. Before stone became the standard, early builders may have created structures from mud brick, timber, or earth, materials that decay rapidly in harsh environments. Only when stone construction became the standard did structures begin to survive long distances into the future. This means that the absence of early prototypes is not evidence of their absence, but a consequence of preservation bias. In another sense, thinking about older pyramids expands our understanding of what ancient societies were capable of without written instructions. It suggests that practical knowledge, passed verbally or through apprenticeship, may have been stronger and more enduring than written records alone. The engineering principles behind large structures don't necessarily require a writing system. They require consistent observation, stable communities, and a culture that values long-term planning. If those conditions existed earlier in human history, the knowledge could have passed through generations without ever being recorded in text. There's also the matter of cultural regression. Not all societies move steadily forward in complexity. Environmental disasters, droughts, volcanic eruptions, or major migrations can interrupt cultural growth. When these events happen, knowledge can be lost. A society capable of building sophisticated structures might later shift towards simpler ways of life due to changing conditions. If such regression occurred in North Africa or nearby regions, earlier architectural traditions might have disappeared, while later societies rebuilt using only fragments of older knowledge. The pyramids may represent a point in the cycle where conditions allowed a resurgence of those skills. Looking at the implications this way, the pyramids become less an anomaly and more a signpost marking a moment when environmental stability, cultural memory, and technical ability aligned. Instead of standing as isolated achievements, they become evidence of a much longer interrupted story, a story in which early societies experimented, innovated, lost knowledge, and rediscovered it across long cycles shaped by climate and migration. This leads into another implication about the pace of ancient innovation. The traditional timeline suggests that agriculture, writing, monumental architecture, and complex social structures emerged in a relatively short span of time. But if older cultural traditions influence these developments, then the apparent rapid rise of civilization becomes less abrupt. Instead, it becomes the visible tip of a longer, slower process. Human societies may have been advancing in ways that didn't leave durable evidence long before the earliest known cities. The possibility that the pyramids are older also adds a new dimension to our understanding of ancient memory. If knowledge survived across long periods of instability, it must have been conveyed through strong oral traditions, consistent teaching, and careful preservation of skills. This would highlight the resilience of early human cultures. It would suggest that communities held onto vital knowledge even as their environments changed dramatically. Such a view portrays ancient people not as isolated from earlier traditions, but as inheritors of deep collective memory. Some of the implications cross into archaeology directly. If earlier societies existed with enough organisational capacity to influence later monumental builders, then their traces might still exist in extremely small or eroded forms. Isolated tools, scattered stone fragments, unexpected settlement patterns, or subtle landscape modifications could represent the last hints of much older civilizations. Researchers might already have uncovered pieces of these earlier cultures without realizing their significance, because the fragments appear too simple to interpret as evidence of complexity. Recognizing this possibility could guide future research toward areas previously considered unlikely, to yield evidence of early development. An older pyramid tradition would also reshape how we interpret global patterns. The appearance of pyramidal structures in different parts of the world might reflect not independent invention alone, but the recurrence of a shape rooted in architectural experimentation far earlier than the known timelines suggest. This doesn't imply global contact between early cultures. It simply means that the pyramid may have emerged as a solution long before surviving examples appeared. If so, later cultures adopting the form may have done so consciously or unconsciously, drawing from ancient traditions passed through memory rather than materials. Thinking this way encourages a broader understanding of how ancient knowledge spreads. It isn't always through written communication or direct contact. Sometimes it spreads through shared human experience, shaped by similar environments, similar challenges, and similar solutions. The pyramid form might be one such solution, refined through countless generations of earlier building traditions. When considering what it means for the pyramids to be older than expected, another implication emerges. It challenges the boundaries we place around civilization. If the structures reflect older knowledge, then the definition of civilization might need to include societies that left minimal remains. Civilization, in this sense, becomes not a sudden invention, but a continuum, one that includes early groups capable of impressive organisation even without permanent cities or writing systems. This perspective doesn't contradict established archaeological findings, it expands them. It suggests that the earliest visible civilizations inherited more from the deep past than we typically assume. Their achievements become part of a longer human story, shaped by cycles of development, loss, and renewal. As you think through these implications, the pyramids start to feel less like sudden masterpieces and more like the culmination of effort stretching far into prehistory. Their precision, scale, and endurance reflect not just the ingenuity of the builders we can name, but also the legacy of cultures whose names have faded. They stand as markers of persistence, not only in stone but in knowledge, memory, and human resilience. As you reach this final stretch of the journey, something subtle begins to settle in. It's the awareness that beneath every familiar chapter of human history lies another layer, and beneath that layer lies another still. Not dramatic layers, not layers filled with lost empires or forgotten wonders, just the quiet, steady accumulation of human experience stretching back across tens of thousands of years. When you imagine the pyramids sitting in the middle of that vast timeline, they start to feel different. Less like isolated monuments rising from sand, and more like the visible surface of something older that rests quietly beneath them. Thinking of the past this way brings everything into a softer focus. You don't have to picture anything extraordinary to feel the significance of what might have existed before the visible record. You only have to imagine the lives of the people who came long before the builders we know, people who walked the same ground, watched the same sunrise, and shaped the land with the same human hands. People whose knowledge may have travelled through generations until eventually it found expression in stone. Their names are gone, their homes erased, their traditions scattered, but their influence may still linger in the monuments that survived after everything else slipped away. The idea that the pyramids could be connected to older traditions doesn't rewrite history, it simply widens the horizon. It invites you to consider how much of the human story is hidden, not because it was unimportant, but because time is relentless. Wood rots, mud brick collapses, floods carry away entire settlements, sand buries foundations, climate shifts erase landscapes. What remains is only what was strong enough, stable enough, or fortunate enough to avoid being swept aside. The pyramids endure because stone resists time in ways other materials cannot. They are visible not because they were the only achievements of their era, but because they were the ones built from materials capable of surviving the long cycles of the earth. Once you accept how much has been lost, the mystery begins to feel less like a puzzle and more like a natural part of being human. So much of our early experience took place before writing, before permanent settlements, before elaborate rituals carved into objects we could later analyse. When you imagine those early cultures, building, teaching, migrating, observing, you begin to sense how easily their accomplishments could slip beneath the surface of time. There's something calming about that realisation. It reminds you that human history is not just the story told by artefacts. It's the story of people adapting to the world in ways that don't always leave physical traces. This perspective brings a certain gentleness to the idea of lost civilizations. It doesn't conjure images of vast forgotten empires. Instead, it suggests the possibility of communities that were stable and skilled, but whose materials were too fragile to endure. It shows how knowledge can persist even when buildings don't. Skills can travel quietly from one generation to the next, surviving migrations, environmental changes and disruptions that erase the rest of a culture. If some of those skills ultimately contributed to the techniques behind the pyramids, then the monuments become not just symbols of ancient Egypt, but the culmination of a lineage far older than the visible record. As you reflect on this, the timeline of human civilization begins to feel layered rather than linear. The approach to the pyramids becomes gradual, shaped by cycles of learning and loss. The builders who arranged each block so precisely were part of a continuum that stretches into eras where little survives. They were inheritors of knowledge refined by countless hands. Understanding that connection doesn't diminish their achievements, it enriches them. It places their work within the much larger arc of human ingenuity. Thinking about the past this way also places a kind of quiet respect on the landscapes themselves. Beneath the deserts of North Africa lie sediments from ancient lakes, traces of vanished rivers, pollen from plants that haven't grown there for thousands of years, and foundations of settlements scattered far below the modern surface. Each layer contains remnants of a different world. When you stand near the pyramids, whether physically or just in your imagination, you're standing on top of many older landscapes. Each one hosted people who lived full lives, even if those lives left almost nothing behind. That awareness brings a sense of continuity. You can picture a time when the Sahara was green, filled with herds of grazing animals and communities gathered near rivers. You can picture those people looking at the same stars visible today, perhaps telling stories about them, stories that later found their way into myths. You can imagine how knowledge moved quietly through these eras, carried by families, preserved through practice, and altered slowly over generations. When conditions changed and people migrated, they took that knowledge with them, and in some cases, it eventually settled in places where the environment allowed structures strong enough to last. The pyramids, in this light, become anchors in time, not because they stand alone, but because they are the rare survivors capable of representing a broader story. Their endurance gives them a presence that can make everything else feel distant, but that distance doesn't mean emptiness. It means that the human story is far larger than the surviving monuments. It spans long periods where the environment erased nearly everything. It continues through ages of movement, change, adaptation, and quiet persistence. Once you take this broader view, the question of whether the pyramids could be older becomes less about rewriting dates and more about understanding how deep the roots of human knowledge might reach. If people experimented with building long before the surviving structures, if they developed surveying techniques in earlier landscapes, if they aligned simple markers with the sun or stars in ages now forgotten, then the pyramids become expressions of a long memory. A memory shaped by trial and error, carried through migration, preserved through oral tradition, and refined in different environments across thousands of years. This idea makes the past feel less distant. It connects the achievements of known civilizations with the quiet ingenuity of people who lived in eras where almost nothing remains. It suggests that great accomplishments don't always need great records. They need communities willing to preserve knowledge across generations, regardless of whether the physical traces survive. If the pyramids represent the point at which that long memory met the right environment, stable ground, durable stone, and a culture capable of large-scale organization, then their origins become part of a story far older than the structures themselves. Thinking about time this way also encourages a different relationship with the present. It becomes easier to appreciate how much of our own world rests on foundations we rarely see. Technologies, traditions, languages, and patterns of life all have deep histories shaped by countless people whose names have disappeared. Just as earlier cultures influenced the builders of the pyramids, the achievements of today rest on layers of past effort. Understanding the depth of those layers brings a sense of calm. It reminds you that human progress is not simply a matter of sudden discoveries. It's the cumulative result of long, slow development stretching far behind us. It also becomes easier to recognize that future generations may look back at our era the way we look back at prehistory. Much of what we build will not survive. Much of what we write will be forgotten. But the ideas, the small innovations, the everyday efforts, those may carry forward in ways we can't predict. Just as earlier generations preserved knowledge that eventually contributed to the great monuments of ancient Egypt, our own contributions may survive quietly, carried through time long after the physical traces are gone. When the idea of deeper timelines settles gently in your thoughts, the pyramids become more than structures of stone. They become reminders of how much humanity has experienced, how much has been lost, and how much continues to shape the present even when hidden beneath layers of time. They remind you that history is bigger than what appears in textbooks. They point toward ages that left only faint impressions, ages populated by people whose skills and persistence still influence the world today. As these reflections drift through your mind, the story begins to slow, not because it has ended, but because it has reached a natural pause. The pyramids remain where they have always been, watching over the desert, grounded in their own silence, and beneath them, beneath the sands and sediments and vanished landscapes, the timeline of human history continues to rest quietly. It waits in the layers of earth, in memories passed through generations, and in the subtle hints preserved in stone. A timeline that doesn't rush. A timeline that holds more than we can see at once. A timeline that still sleeps beneath us.